o'clock already.
Yes, sir. Good evening, respected professor and my dear students. I welcome you all to the fifth session of rapid fire discussion for exam going students. Today we will be covering, professor will be covering the topics on anesthesia machine, vaporizers, along with some Osces. Over to professor and students, please.
Also some equipments also. So, and because the machines we have already had one exclusive class for machines, we will rapidly go through that and revise that. And vaporize also mostly exam oriented questions will be there, and we'll dwell a little at length in the other equipments like defibrillator, the neuromuscular monitoring devices, then oxygen delivery devices, and suction catheters, the ICDs, and all those things. And finally, there will be a model Osce presentation, which will consist of about 15 to 20 questions. And actually, in the exams, I was told that they give you about 25 Osce questions. And each question carries about 6 marks, so that 150 marks are allotted to Osce itself. So if you do well in your Osce, it is easy to get through your exams. So with that in mind, we will just proceed to the slide sharing. And is it visible?
Yes, sir.
Yes, sir.
Visible, sir.
Okay, so I'm just going to show the. So I don't know how many of you had an opportunity to see this machine. It's one of the oldest anesthesia machines which was developed. Then that machine became like this. Then it became like this. And you are all familiar with this because most of you are now dealing with machines like this, very high and sophisticated machines. So the question on this, what are the differences between these anesthesia machines you notice? They show you pictures like this as an evolution of the anesthesia machines. Just observe the machines and tell me what are all the additions or improvements that have been done. And what is the major difference between these first 3 machines and the last one?
In the first two, vaporizers are not there, so.
It is a pneumatical.
This is a vaporizer, this is a vaporizer. Vaporizers are there.
It is pneumatical, sir. It is electrical and pneumatical.
This is mainly all of them are pneumatically operated, that they work on the gas pressure. Whereas here it requires the electrical supply also. So the workstations, the modern workstations are operated both by electrical as well as pneumatic power, whereas the older machines were mainly pneumatically operated. But in addition to that, by looking at these pictures, can you tell me what are all the other improvements that have been made over a period of time?
In first picture, there is no soda lime, sir. It is semi-open, sir.
Very good, very obvious, excellent. Then, how many cylinder provisions are there in the left?
One, sir, and another is 2, sir.
There are 2 provisions for 2 oxygen and 2 nitrous oxide, whereas in the older machine there was only 1. Okay. Then, what else?
Oxygen and nitrous oxide only.
Oxygen nitrous oxide has been there right from the beginning.
But they added air in 4th one, sir.
Okay, right. And what other improvements you are seeing?
Monitors, sir. They attach monitors, sir.
Monitors is there, but that's optional. But more than the monitor, what is this I am pointing out?
Bellows.
You see here one, you see here one. Is it there in the first 2 pictures?
Bellows, sir.
Is it called bellows? This anesthesia ventilator. Okay. So here we used to do it manually. Control ventilation is done manually by squeezing the bag by the anesthesiologist. But later on, to remove that the burden of physical strain of manually ventilating the patient, they have incorporated anesthesia ventilators, which are very useful. And you see the pressure gauges. Where are the pressure gauges here? It's all on the side. Whereas here there is a panel. And here the pressure gauge is only for which purpose is there. It is only for the small cylinders which are attached to that. Suppose you get a pipeline supply. Is there a display of what is the pressure in the pipeline here?
No, sir.
No. Whereas the modern machines show you the display of pipeline as well as the cylinder pressure whenever you use it. Okay. So by observing, you must be able to pick out all the differences. So 1, 2, 3 are pneumatically operated with gradual improvements like addition of spare cylinders, circle system with soda lime, new vaporizers, anesthesia ventilators, pressure display for cylinders and central supply. And of course, the monitors are optional. Some you have to buy them as an extra addition. It doesn't come with the machine. But nowadays we do buy them all together when it comes to a workstation. And the fourth is a modern workstation driven pneumatically and electrically with monitors also incorporated. Okay, so that is the difference. So from this introduction, now we will be going through in an orderly fashion what will be the source of gas supply to the machines, anesthesia machines like oxygen and nitrous oxide. Where do they get the supply from that? And what are all the pressure segments in an anesthesia machine? That is the common way the examiners will ask you how many segments or how many pressures, based on the pressure, how many segments are there in an anesthesia machine? Can you tell me the answer for that?
The high pressure system, intermediate pressures, and low pressure system.
Low pressure. So there are 3 segments. Okay. So we will be seeing all those things in the coming slide. So first thing is, how is gas supply to machines done? What are all the options for supply of gas cylinder, gas to the machines? Where all they
Via
can be
cylinders or pipelines
where
system.
central supply or machines mounted on the machine. These are the 2 sources of gas supply. And supposing it is a central supply, what are all the methods of storing the gases there?
So through liquid oxygen tank.
It is only for oxygen. Okay. What about oxygen and the nitrous oxide and the air? If you want to supply all those things, do you have a tank for all those things?
It's a manifold.
Manifold. You have giant cylinders. Okay. So the options are, what is this?
Cylinder manifolds.
This is the manifold. Okay. Bulk cylinders in manifold with 2 banks. So supposing they show the pictures like this, you have to identify that there are 2 banks, one reserve bank and one will be in use. So when all the cylinders here get exhausted, automatically these cylinders will start supplying. So there is a provision to identify when the pressure in these running cylinders are decreasing, automatically the spare or the bank cylinder, reserve cylinders will open and they will start supplying. Okay. And you have all safety features of what is the pressure and what is the lower limit, alarms, everything is there. So this is the manifold room or manifold of bulk cylinders, which is used mainly for hospitals with limited beds. But in a major hospital like your Mayot or SIMS or other hospitals, these cylinders may not be sufficient. So you have to go for bulk tanks, liquid oxygen tank and other bulk method of using it. And what is this picture showing you? These are all the cylinders which are used in the machine. So why is this being shown here?
Backups.
This is the correct way to store the cylinders. Individual cylinders, this is the correct method of storing cylinders. If you go to hospitals, invariably this is not followed. All of them will be lying horizontally on the floor, stacked one upon the other. That is not the way to store them. So the correct method of storing the small cylinders is to keep them upright in a standing position, not in a horizontal position, stacked one over the other. And what is this being shown here?
Transport.
This is the transportation. So the OT assistant should not carry the cylinder on his shoulder or anything. This is the correct method of transporting the cylinder. Now, this is a common question that will be asked in the exam about the small cylinders. Supposing one cylinder gets exhausted and you want to connect a new cylinder, you have to do something called cracking open the cylinder. What is that cracking open? What is being done is a cracking of cylinder. It is written here. What is the purpose?
Before opening it fully, we have to open it slowly to avoid any dust or obstruction causing explosion or something.
Very good. So what is cracking open a cylinder and why should it be done? That will be the question that will be asked. So before fixing a new cylinder to the hanger yoke where the cylinders are fixed, the valve should be opened gently to let out some gas. This is called cracking open the cylinder. But the reason is this is done to remove any dust or oil particles in the gas outlet, which can cause fire and explosion. Okay, so this is a very, very common question, and you should not make any mistake on that, because you don't get an opportunity to see how a cylinder is being fixed nowadays in the machines, because every major corporate hospital you get always the central supply and you don't have an opportunity to see how the cylinders are even fixed to the anesthesia machine. So this question may sometimes bold you by not knowing this. So this is the reason why I'm telling you this. So this you should be aware of. Now, for large users, you know, this is the
Liquid
oxygen tank,
Liquid
liquid oxygen tank. And this is how the oxygen tank gets filled up. So the lorry comes here and you have a pipeline going to that and this. So some questions about this are, what is VAE?
Vacuum insulated evaporators.
Evaporator. Okay. So what is the purpose of that? What gases can be stored in them and for what purpose?
So it is to maintain them in the liquid state and to prevent the increase in the temperature, to make them store under the critical temperatures.
Okay.
To
But
decrease
what
the
gases? The
increase-
first question is, you are seeing oxygen that is being stored in your hospital. Any
Yes.
other gases can be stored like that?
Internox.
Etanox. It's mostly industrial. Okay. For
Yes, sir.
hospitals, it's very, very limited supply. So only oxygen is stored as a cryogenic liquid in the for our hospital purposes. But nitrogen and argon are industrial purposes. They are not commonly used in our medical use. Okay. So what is the temperature of the stored liquid oxygen?
Minus 156 degrees
Minus,
Celsius.
minus is right.
187 degrees.
183. Okay, it's approximately minus 183. And what is the standard operating pressure of a liquid oxygen tank?
1000 operating pressure is 700 kilobars.
13,700.
16 bars. Standard operating pressure of bulk cylinders is 16 bar, that is 232 psi, and sometimes it can be as high as 35 bar also. Okay. So what is shown here?
Wall mounted
Pipeline inlets.
Gas outlet, central supply outlet in the wall. And what other things you are seeing? You must describe all the things about
It is
the color
color
coded.
coded.
What is the name of this outlet? Is there any specific name?
non-interchangeable quick couplers or non-interchangeable screw
Supposing now
thread.
there is no hose at all, isn't it? There is no hose attached to this. So how does the gas does not leak from this? See, when you fix the hose, gas will be delivered to the machine through the high pressure hose. But now I am showing the outlet without the hose being inserted. So why gas is not leaking through that?
As a disc, like
It has got
One-way
a
pressure.
self-sealing valve, SCLF, self-sealing valve, otherwise known as Schrader valve. This is also a very common question in the exam. You have to be very careful in saying that. So color-coded wall outlets with self-sealing valves, which is also called Schrader, SHRADER, Schrader valves. Okay, so when you remove the hose, the probe which is going inside, automatically a disc will come and close that, so that no gas will leak out. Okay, so that is why it is called self-sealing valve. What is this? This is the one which is going to go inside.
Shadow
Color-coded
probes.
Schrader probes.
Color-coded
Color-coded
probes.
Schrader probes.
High pressure hoses with diameter specific probes. So this portion is called the probe. Okay, and the diameter here at the neck will be different for different gases, so that you cannot interchange. You cannot put the oxygen hose into nitrous oxide or vice versa. Okay, so each one has got a different diameter at the neck level. So this is color coded high pressure hose with a diameter specific probe. What is this? So this is fixed on the wall. This is called wall mounted. These are all, where are they fixed?
To the ceiling, sir.
To the
Ceiling.
machines.
So this is called the ceiling gas outlets with color coded hoses. Okay. So some hospitals, to avoid, because if you fix it on the wall, the hoses may be running on the floor when it comes to the machine. So people are likely to trip and fall. So people thought of directly fixing it on the ceiling, so that it will straight away come down without running on the floor, avoiding the hazard of people tripping and falling. Right? Then what is this?
Pin index, color-coded
Diameter index.
Where does it go? This portion, where does
the
it
machine.
where does, to the machine.
To the
So this is
machine
the block which is attached to the machine to deliver the gases, and you have these blocks for which gases?
Nitrous and oxygen.
Oxygen and nitrous oxide. Okay. And what is one peculiarity do you notice in this? What is this portion called? What is this portion? What is this portion?
They can
If-
connect it upside down.
You can connect it anyway, upside down, and this is the inlet, the outlet for the gas. From the hose, it will come through that and go to the machine. Okay, so these are the pin index holes. So depending upon the position, you can fix it this way or that way. So it can be used both ways. So non-interchangeable screw threaded connection for different gases. This is the name for that. What is this? Mostly you won't be seeing it in your day-to-day because this is
to
on,
other machines.
where is it connected?
Back side of
To the back,
Back
of
of
the
the
machine.
machine. Okay, attached to the back of the machine. So this is how the machines are connected on the back side. And what about this?
They're fixing the pipeline to the
This is a different type of wall outlet. Okay, this is the older type of wall outlet. Models are changing. Okay, here there is no flushing. The Schrader valve is not protruding like that. This is flushed with the surface and the probe is going in. So this is a modern way of what is called newer outlet designs. Okay, this is how the design is made in the modern theaters. This is a very older method. In olden theaters only you will find this. What are the components of high pressure segment? So you said the pressure, based on the pressure, it is divided into high pressure, intermediate pressure and low pressure segments in the anesthesia machine. So what are the components of high pressure segment?
So from cylinder manifold to the first stage pressure regulators.
Okay, in between what are all the things? Components, you must, I'm not telling you which segment is made of what are all the parts made up, making or incorporated in that high pressure segment? A cylinder is there, all
Cylinder yoke
outlet is,
assembly, bodoxil, pin index safety system.
okay. So this is the first of all, what is this? This is called
hanger yoke assembly.
hanger yoke assembly. Very good. This is called hanger yoke assembly. Then what is this?
Bordens
Borden
pressure gauge.
Pressure gauge. So this is the second component. What is this?
Pressure regulators.
Pressure regulator. Okay. So these are the three important components apart from the pipeline gas outlet or the cylinder which is fixed to the machine. These three are the important components of high pressure segment. Name some components of the intermediate pressure segment. After this pressure regulator, what are all the components are there, which are called intermediate segment?
Second, oxygen flush valve, pipe. Second
So this
pressure
is the
regulator.
pipeline inlet
Pipeline
connection.
inlet connection.
Then there is a
Oxygen
oxygen flush. Then there is a
Oxygen system.
Kilometers.
flow control valve. Okay, all these things are coming under intermediate pressure segment. Name the components of low pressure segment.
Flow meters and vaporizers.
And
Flow meters, vaporizers.
Backbar.
Then
Uh,
what is this?
Common outlet.
Common gas
outlet.
outlet. Okay, and the APL valve. Okay, all these things are the vaporizers, pressure release, common gas outlet, APL valve. All of them constitute the low pressure segment. Okay, so how are pressure systems in anesthesia machine classified and what are the values? Of course, we have seen that pressure system, high pressure, the value is about 220 psi for the cylinder pressure, oxygen full cylinder, nitrous oxide 750 psi, and it is reduced to 45 psi when it is supplied to the pressure from the pressure regulator. Intermediate, it is reduced from 45 to 15, 14 to 15, and low extends from 5 to 7. So gradually the pressure is reduced. Why the pressure has to be reduced?
To
This was
avoid
high
damage
pressure
to the
conduit to barrel
barotrauma. That is the main reason. Now, what are the units of measurements of pressure and what is their correlation? This is a very important point, not only from exam point of view, but from your day-to-day knowledge also, because the pressure will be described differently, the different units in different situations. So the commonly used method is PSI, which is pounds per square inch. And this pounds per square inch, when it is shown in the pressure gauge, it is called PSIG, which is pressure gauge. And is it the, if atmospheric pressure is mentioned as PSI-A or absolute pressure. So pressure absolute is equal to pressure shown in the gauge plus the local atmospheric pressure. This is very important difference you have to know. So when an oxygen cylinder reads 0, does it mean it is totally empty?
The vapor pressure is at 0.
Vapor
not,
pressure for oxygen?
Yes, yes, sir, it is 0.
So you say it will not, there won't be any gas at all.
Less than 25%.
25%. 25% is too large a volume. See, even when the oxygen cylinder pressure gauge is reading 0, because atmospheric pressure is higher, absolute pressure of the cylinder is gauge pressure plus atmospheric pressure. So some amount of oxygen will be still present, but it cannot be delivered. Okay, so you have to use a suction or a vacuum to remove that. So please, this is a common question they will ask you. When the pressure gauge reads 0, it does not mean that the cylinder is totally empty. Still, there will be some amount of oxygen gas will be present, which cannot be removed because the absolute pressure is gauge pressure plus atmospheric pressure. And if you want to remove and make it totally empty, you have to use only a suction or a negative pressure to draw out that little gas that will be there. So please remember that. And the correlation is normally pressures are described in kilopascals. So our Pascal, what is the unit? Is it a standard unit, SI unit or a British unit?
SI unit.
It is SI unit. Okay, all the others are conventional units. So pressure is not a bar or millimeters of mercury, centimeters of water. All these things are not SI units, standard international units. So only Pascal and kilopascal are SI units. So the equivalent of that is, normally this two correlationship is very, very important. 100 kilopascal is equal to 760 millimeters of mercury. So how much will be 1 kilopascal?
7.6 millimeters.
7.6 millimeters of mercury. Okay. So sometimes your blood pressure measurement is also given in many books as kilopascals. Okay. So 1 kilopascal is equal to 7.6, or roughly you can remember as 7.5 for easy calculation. So this is a very common conversion you have to remember. 1 kilopascal is equal to 7.5 millimeters of mercury. And also the equivalent of centimeters of water is 10.3. 1 kilopascal is will be equal to 10.3 centimeters of water. So these three correlations are very, very important. Sometimes you have to use them for conversion. What is the effect of altered barometric pressure on delivered concentration of volatile agents? Supposing you deliver a gas at high altitude, like Ooty or Kodaikanal, there the atmospheric or a barometric pressure becomes very important. So vaporizer is used at a higher altitude, will it deliver the correct concentration that the dial is set, or it will deliver low or high?
So only the partial pressure will be less, the concentration will be same.
Same. But delivered percentage will increase based on the atmospheric pressure, but the concentration will be same. I will show you. So the effect of altered barometric pressure, required dial setting is equal to normal dial setting, that is volume percent, multiplied by 760 by ambient temperature. For example, if the ambient temperature is 630 millimeters of mercury and isoflurane is set at 1%, actual output will be 760 divided by 630, it will be 1.2. Okay. So when you set 1% isoflurane in the dial, it will actually deliver 1.2%. But does that mean that it will supply more concentration or more vapor? That will not happen, because set concentration is 1, delivered concentration will be 1.2. But if you take the partial pressure of 1% isoflurane at 760 millimeters, it is 7.6. And partial pressure of 1.2% isoflurane at 630 at ambient pressure, that is also equal to 7.6. So even when the concentration delivered is slightly higher because of the low ambient pressure, the partial pressure will be the same. So vaporizers need not be recalibrated to higher atmosphere. That is the answer that is expected out of you, okay, based on the pressures. What are small cylinders? Where are the small cylinders connected to the machine?
To the back of the machine.
What is that portion called? We just now saw the first thing, first component of the high pressure system.
Yoke assemblies.
Hanger yoke assembly.
Hanger
Very, very important. This question is a repeatedly asked thing. So all the parts you should be very thorough. That's why I have given it again. So the small cylinders are mounted on what is called the hanger yoke assembly. Hanger yoke assembly. Okay. Yoke
Yes.
is something what you see in the fields when the farmers plow the land in the olden days with bullocks. They put a wooden rod on the neck of the two bullocks and then fix it. That is called the yoke. Okay. So the same way, this the one which yoke means one which holds the weight of a particular thing. So that is what is being done here. So they are connected to the hanger yoke assembly. Describe the parts of the hanger yoke assembly. What are all the components? This portion, this portion, this portion, everything you should know the names. Any idea? If you don't know, say no. I will go quickly. We'll go through because we have a lot to cover.
Yes.
So So the parts are first body. This portion is called the body. Okay, the framework which is fitted to the machine. Okay, the second portion is the retaining screw. This white portion which you see, which can be there. There is a metal rod like thing. Here it has been lifted out, and this is the one which retains the cylinder to the machine. So this is called the retaining screw. Then the third portion is the nipple. This is the portion through which the gas will enter the machine. So this is the nipple, and index pins. The pin index pins are below the nipple always. Okay, 2 pins will be there, and there will be a board of seal around the nipple. So the important entry point is the nipple, supported by the or covered by the board seal for tight gas fitting, and the pins are there. And the board seal, they may ask you the material out of which it is made. Can you tell me what is the material out of it? Is written here non-combustible material, but what there is a name for that? Can you tell me the name?
Neoprene.
It's called neoprene rubber. Okay, very good. It's called neoprene rubber inside a metal ring. So the peripheral, I'll show you another picture to see that clearly. There is a small metal ring inside which this neoprene rubber sheet will be there with a hole. So that will be inserted here, and the pins will be there. And there is a filter inside to prevent any dust particles going in. And so this is a close-up picture. You can see this is the main body. Then this is the nipple. This is the board seal has been removed here. It is not fixed there. These are the 2 pins, and this is the retaining screw. So remember, body, retaining screw, nipple covered by the washer, and filter. So these are all the parts of hanger yoke assembly. What are shown here? This is a very, very familiar picture for you. All of you are using machines which have these parts here. So you must identify all the parts that are shown here.
There is a switch for manual and ventilation.
Okay, very good.
Ventilation.
Okay.
There is a pressure releasing valve, APL
Okay.
valve.
APL, what is the expansion?
Adjusting pressure.
Okay.
Pressure limiting.
Adjustable pressure limiting valve. Okay, so that is adjustable pressure limiting valve, and it is minimum to maximum 70. This is number, because they may suddenly ask you what is the minimum. Is it 0? There is no 0 here. It is written MIN, minimum to maximum 70 watt unit here. Millimeters of mercury or centimeters of water?
Centimeters of water.
Centimeters of water. And that is why the previous slide I had put here all the various units that are here. So here it is centimeters of water. Okay, and this is the airway pressure gauge. This is not a cylinder pressure gauge. This reflects the pressure inside the breathing circuit. So it is called the airway pressure gauge. So APL valve knob, airway pressure gauge, lever to change from back to ventilator. These all the 3 are seen in this. What do you see here? Pressure gauge for oxygen is shown here, and the principle it is working on, the Borden principle, is also shown in the picture. So oxygen pressure gauge and Borden principle. What is this? This part has been removed from the machine and displayed here. So this is a
Pressure regulator with the pressure gauge.
This is the entry point for the gas from the pipeline or from the cylinder. Okay, this is the one which goes into the body of the hanger yoke, what we saw in the earlier picture. Okay, so this is fixed mechanically inside that the body of the hanger yoke, and from there the gas enters. The pressure is registered here, and this is the pressure regulator or pressure reducer. Okay, and from there this is the outlet to the flow meter. So these are the components of that. Unit of anesthesia machine consisting of gas inlet from the pipeline or the cylinder. Then there is a pressure gauge, pressure regulator, and these are downstream outlet. That is the outlets going to either the flow meter or to the oxygen flush. All these things will be delivered from here. Yeah? And this is a very old method of measuring the pressure. Anybody knows the name? This is not used in anesthesia machine, but this is used in the cylinder, which used to be used in the wards in the olden days before they had the central pipeline supply. Okay, so this is called the two-stage oxygen pressure regulator. So this end will be fitted to the oxygen cylinder, which is portable, and by tightening this screw, you can reduce the pressure from the 2000 psi to whatever pressure you require. So once the gauge will show the actual pressure in the cylinder, and by tightening the screw, you can reduce it to 12 or 14 psi, whatever you want to safeguard the patient's. This is the outlet. Okay, so this goes into the cylinder. These two are called the two-stage regulator. This portion, what is it called? This is the cylinder body. This is the neck of the cylinder to which this portion is attached. What is this portion called? All these things are little difficult for you because unlike the olden days, you are not seeing these cylinders being brought into the theater every day and being fixed and all those things. During our PG days, we had mainly we had to depend only on these cylinders because central pipeline supply system was not in full use those days. So this is called the, anybody know the name? This is called the valve assembly for cylinder, front and back. Okay, this is called the valve assembly or valve block. Some people call it as valve block. So it is the front and back. So this is the hole through which the gas will be delivered. When you open the stem, the gas will be delivered through this hole. This is called the exit hole or delivery hole, and these are the holes for the pin index to be fitted in. This is the, so this goes to the machine side, and this is the back side where the retaining screw will be tightened here, and below that there is a pressure relief device. So in any excess pressure developing, this will either get blown out or melt, and it will deliver the excess pressure. So this is one of the safety measures that is incorporated in the valve block, which is also important. Sometimes they keep the cylinders in the viva and ask you to identify. So remember, this portion is called the valve assembly or valve block, and it has a front side, machine side, and a back side. Machine side has the exit port with the holes for the pins, and the back side has got the retaining screw depression as well as a pressure relief device. Now this portion goes into the neck of the cylinder. Okay, again this valve block is shown in a diagrammatic manner with all the parts marked. So I already have shown here. What is this written here? Can you read that? This is called the stem.
Conical
And this is called the gland net. Okay, so name the parts. These are all the names. So cylinder stem or valve, which has to be opened. Then there is a gland net, there is a valve block, there is a scaling washer or the Bodex seal, there is a port for the gas, and the pin index holes. There will not be so many holes, only the two holes will be there, and other things are just mentioned to show you that it is the holes may be kept in these positions for other gases. So that is why there are now actually two holes will be there. Only two holes will be there in most of the cylinders. Only one cylinder will have one hole. Which is that?
Pentanoxylene.
Pentanoxylene. Pentanox has got only one pin. Okay. So what is shown here? This is the Bodex seal. Okay. This is the neoprene rubber with a metal ring outside, and the thickness of it is about 2.4 millimeter. Okay, and as you keep on using it, it may get worn out, and when it becomes thinner, the gas will start leaking. So that is an indication that you have to change it to a new washer. So every time when the person comes to service, they will remove this old seal and put a new one so that the thickness is maintained. Can you identify what is shown here?
Screw
Opener.
opener.
These are all the keys. They are not got opener, bottle opener. That's not the way it is. It's, of course, it's used to open the cylinder, but this is the keys for various types of keys to open compressed gas cylinders. Okay, and what is shown here, and name the parts.
Pressure regulators.
It's a
Spring
pressure
one.
regulator because you can
The
see
spring one.
EA. So pressure regulator, the valves are, this is a screw which can be adjusted to decide how much pressure you want to compress the spring. And this is the diaphragm, which is a very important part. This one will get worn out. So during service, they will change the diaphragm also. It's a rubber diaphragm to withstand the high pressure. So there is the high pressure inlet. So the gases enter through this. Then there is a valve seating. Then there is a low pressure chamber, and the once the pressure gets reduced, it is regulated through the outlet to the flow meter. So these are all the components of the pressure regulator. What is shown here?
Pin index. Safety
Pin
system.
index holes. Okay, can you
Yeah.
identify based on the positions?
First is air.
First is air. Okay, quickly. So let us
Last
see.
one
That's
is
first is oxygen, 2.5. Okay. Second is nitrous oxide, 3.5. Air is 1.5, and the carbon dioxide is 1.6, and NOx only 1.7. Okay. So these are all the commonly used gases in their pin index. What are the various sizes of cylinder, their capacities and pressures and tire weight? Sometimes this can be asked, but sizes can be in the alphabetical order: B, D, E, F, G, H, M, and all. Capacity varies like this. Pressures, full cylinder for oxygen is 1900, for nitrous it is 750, but the weight varies as the size of the cylinder increases. You can see the weight of the empty cylinder. Tare weight means weight of the empty cylinder. Which type is commonly used among this in the machines?
E-types.
E-type. So E-type will have a capacity of 660 liters with a full cylinder pressure of 1900 for oxygen. Okay, so remember these two values. 660 is the capacity of a E-type cylinder, whether it is oxygen or nitrous oxide, but the pressure will be varying. Now, which type cylinder is fitted? Of course, the E-type is cylinder. Now, what is this being shown here?
Color
Pipeline pressure.
pipeline pressure and
Cylinder pressure,
Cylinder
both
pressure.
in the pressure gauge form as well as in the digital form. Okay, so you can see the top row is the pressure gauge for nitrous oxide, air, and oxygen. Below is the cylinder pressure for the same thing, which is 0 because cylinders are not open now, so they are kept in closed position. So all the gauges are showing 0. Whereas pipeline pressure, it's reading the pipeline pressure. The same pressure displayed numerically on the right side. Okay, so cylinders are closed, all of them are showing 0, and whatever pressure the other three are delivered by the pipeline is shown there. What information is available from the cylinder label? Usually the cylinders, when they are delivered, they will be delivered with a label around the neck of the cylinder. Okay, so this will be the picture which shows the cylinder, the label. So the contents, sometimes if they keep it in the exam, you have to know there are 10 points which you can information that you can get: name of the content, chemical symbol, physical state, whether it is a liquid or a gas, what is the volume, total volume, whether it is flammable or non-flammable, what is the service pressure of the cylinder, what is the cylinder size code, product license number, principal hazards of cylinder and its contents, and date of hydraulic testing stamped on the cylinder. All this information will be there. There are two valves again shown here. Can anyone identify them?
Bullnose, sir.
One is called the bullnose, another one
Wheel.
hand wheel. Yeah. So bullnose and hand wheel valves. Okay. So these are the valves again which go to the top on cylinders, which are usually used in the wards in small hospitals. Can you identify this? This is a very newer method, newer cylinders, which have their own pressure gauge fitted onto the cylinder itself. Okay, so you don't have to have a separate pressure gauge. So cylinder with integrated pressure gauge. What is the service pressure? This is a common question that will be asked if they ask you questions on the cylinders. What is the service pressure of a cylinder?
It is 2 times the filling pressures.
2 times. Service pressure is defined as the maximum pressure to which the cylinder may be filled at 70 degrees Fahrenheit, not centigrade. Service pressure is defined as the maximum pressure to which the cylinder may be filled at 70 degrees. So if you say the pressure of a full oxygen cylinder is 1900 to 2000 psi, that is the service pressure. That is the maximum pressure you can fill it at the 70 degrees. And how much pressure they should withstand? They should be able to withstand 1.66 times the service pressure. Okay, so it should be so that no explosion can happen. So the capacity to withstand will be 1.5 times more than the pressure that you see. For example, when you say the full cylinder pressure of an oxygen is 1900 or 2000, up to 3000 it should be able to withstand. Even if the pressure is increased to 3000, it should be able to withstand. So that is a safety margin for that. Okay, that is to prevent explosion. So service pressure is the maximum pressure at which the cylinder is filled or may be filled at 70 degrees Fahrenheit. What is shown here? We are coming from the cylinders to the delivery system now. We have seen the first is the sources of gases from the manifold or the liquid tank, then how it is attached to the machine, how the pressure gets reduced, and now we have come to the point where it has to be delivered to the patient safely without barotrauma. So what is this portion called?
It's a flow meter assembly.
Flow meter. Come out with the answer fast, because how many flow meters are there? Is it a single flow meter or double flow meter?
Meters.
Single
flow meters.
The single flow meter for 4 gases. Okay, so there are, you can see the names written very small here. So oxygen, nitrous oxide, CO2 and air. So all the 4 are written. Older machine, oldest machine only will have CO2, and somebody is holding the knob for oxygen to open that, and nitrous oxide is also flowing already, whereas the carbon dioxide and the air are at the bottom. Okay, so they are single flow tubes, flow meter for different gases. Okay. Now comes the newer machines. What is this? What are you seeing here?
Flow meter assembly with 2 tubes, one for
two flow
low
meter,
flow, other
two
for
flow.
high
This is
flow.
called flow tube. Okay, flow
Yes,
tube in a flow meter. Okay, so you can say it is a twin flow tube flow meters. So twin flow tube flow meter with control knobs. Okay, so all the 3, there is no carbon dioxide like here, but oxygen, air, and nitrous oxide are used, and all of them have 2 flow tubes. Okay, there are 2 flow tubes for oxygen, 2 for nitrous, 2 for air. Okay, what is the purpose? Why they have to incorporate 2 flow tubes?
So one is for one is to maintain a low flow, and other one is for
Ah,
high flow.
after the concept of low flow anesthesia has been incorporated in our day-to-day practice, they wanted to deliver exact measurement of the gases with less than 1 liter. Okay, because low flow, there are 3 flows. What are the 3 flows that you have to maintain? Suddenly the examiner may jump to the question on low flow anesthesia. What are all the flows?
Low flow and
High
metabolic
flow
Flow
and
and minimal flow.
medium
Metabolic.
High flow, metabolic, minimal flow, metabolic flow. Okay, low flow or metabolic flow. So gradually you have to reduce from 2 liters to 1 liter, 1 liter to 500, 500 to even 250 for oxygen, which is the basic minimum. Okay, so for that you have to have very accurate flow meters. That is the reason why nowadays the machines are coming with twin flow tubes flow meters. And what are you seeing here?
Digital marking of oxygen nitrous oxide flow meters.
digital flow meters.
Flow meters.
Digital.
Of 3.
It's only a single flow tube, isn't it? So first
Yes,
thing is you have to see is there's a single flow tube, but all the 3 gases are digitally displayed with also the pressure gauge being shown here. Okay, so they are all showing the pipeline pressure. There is a control knob. There is a digital display of the flow meter. Okay, so this is a single flow tube with a digital display of flow, control knobs, pipeline pressure gauge for all gases shown in the display panel. Oh, what is this?
Combined
can-
digital and manual flow meter.
This is a touch screen. Okay,
Touch
somebody is trying to touch that and adjust the flow that is there. So this is the electronic flow meter with touch screen. Okay, so this is the supposed to be the latest among the flow meters. You don't see any flow tubes at all. So you can just touch the screen and adjust whatever flow you want. And you can see here nitrous oxide, it shows 2, and oxygen it shows 1.5. Okay, so you can increase or decrease depending upon your requirement. So this is the latest electronic flow meter. What is shown here? This is slightly different from the older twin tube flow meters which you saw here earlier.
Yes, sir.
Here also you have all the 2 flow tubes are there, one for low flow and another for normal flow.
Color
Anything
code.
else you find additionally other than that?
The color coded.
The color coding is there.
First
Okay.
is nitrous oxide, last is oxygen.
First,
It has separate flow meters for auxiliary oxygen and
air and oxygen auxiliary
and
flow meters are flow tubes are there, and twin flow tubes for all the 3 gases. Plus the knobs are protected by a rod here to prevent accidental movement of the knobs to alter the pressure. Okay, when you keep a low flow, suddenly by mistake this knob should not be turned and flow should not get altered. So to protect that, you have a rod to prevent the accidental handling of that. So twin flow tubes for 3 gases are there, protective bar to safeguard accidental knob rotation, auxiliary flow meter for air and oxygen. So all these points have to be told. Now this is the inside of a flow meter, flow tube with a control knob. This is the picture where I have masked all the names. Can you name all the parts of this whole system? The knob with the flow tubes. First of all, starting
there's a
from here.
knob.
This is
Knob.
the knob. Okay. What is this?
Pins.
Pin. Okay. So this is the gas where it is
Gas
coming
flow.
entry and it has to go into the flow. What is this? The black thing?
Bobbins.
This is the bobbin or the float. What is this on the top?
Stop.
Stop. Very good. So there is a stop here and there is a stop here. So if you see the name of that, this is the flow control knob, which is fluted. What do you mean by fluted?
It has serration.
Serrations or depressions. Okay, so they differ. That is also one of the safety features. If you see the fluting in the oxygen, it will be bigger, whereas for nitrous oxide it is finer, and the air it is in between. So even if you close your eyes and touch, you should be able to identify which is oxygen, which is nitrous oxide, and which is air. Okay, that is one of the important safety features that is incorporated in the flute. And there is a valve stop. There is a needle or a pin which is allowing the gas to enter. This is the gas inlet. This is the valve seat, and there is a float stop which to prevent the float going down. This is the float or the bobbin. There is a tapered flow tube. There's a flow stop on the top, and also gas outlet manifold is on the top. Okay, so these are all the parts of the flow meter. What are the safety features on or downstream on the back bar of the machine or anesthesia machine? Well, these are 4 things we'll have to remember. One is oxygen failure warning device. Second is a spring-loaded non-return valve. Then there is a pressure relief valve, and there is an emergency oxygen flush. These are the 4 things which are loaded on the back bar of that. And the oxygen failure device will be either a pressure failure device, which is also audible, which is called the Ritchie's whistle. Okay, and this is the oxygen flush. This is the common gas outlet. These are all in the older machines, which you normally don't see. So what is the most important goal before using an anesthesia machine? Or what is important precaution you can say that you have to take before using an anesthesia machine?
To keep an ambu bag ready before.
Excellent, very good. So the key point is there is any possibility that the workstation or the breathing circuit is a potential cause of difficulty with ventilation or oxygenation. Switching to a self-inflating resuscitation bag is an appropriate decision. That is given in Miller's anesthesia. So whenever you go to a new OT and you are joining a hospital, first and foremost thing, make sure that you have an ambu bag in the OT. That is the most important precaution that you have to take, so that you can always ventilate a patient when there is a problem with the machine. Now, supposing if they ask you to trace the path of gases and vapors to the patient, you trace them starting from the wall outlet or from the cylinder. I am giving you the starting point. When you trace where all it's going, first thing I'll show you is the source of gas supply. It may be from the wall outlet or from the cylinder from hanger assembly. From there, where does it go, the gases?
The first stage pressure regulator to the
Pressure regulator. So high pressure reduced by pressure regulator before gases reach the flow meter. So what is the third step or third stage?
From the flow meter, it enters
Goes to
the
the flow meter.
vaporizing.
So oxygen failure devices are incorporated before flow meters. Okay, that is a very important point that you have to remember. So after that, when it goes to the flow meter, the beginning of low pressure segment. Okay, so from there, where does it go? Through the flow meters, where does it go?
The vaporizing chamber.
Vaporizer. If you are going to use the vaporizer, it will go to the vaporizers fitted next to the flow meter downstream of the flow. From there,
Common gas outlets.
common gas. Finally, gases and vapors are delivered through common gas outlet at atmospheric pressure. Okay, so these are the steps in the delivery of gases. From the wall or the cylinder, goes first to the pressure regulator. Pressure is reduced. Oxygen failure device is incorporated after the pressure regulator. Then it goes to the flow meter. From flow meter, it may enter the vaporizer if you are using the vaporizer. And finally, gases will be delivered at the common gas outlet. Okay. Now we have pictures of some people. Identify the person and the equipment.
Sorry,
Edward Gaskin
Gas.
Boyle.
Edmund Gaskin,
Edmund.
Henry Edmund Gaskin Boyle, HEG Boyle. Okay, he is Henry Edmund Gaskin Boyle, who invented his first prototype of anesthesia machine. What he built was looking like this. Then this is the later modification. Okay. Again, I am showing a true picture of what you saw in the earlier black and white.
Valve assembly with
This
pin
is the
index.
valve, oxygen nitrous oxide with the valve blocks. Name the components of the gas cylinders. The entire cylinder, what are all the parts?
So
Body,
neck,
Body, neck,
valve,
and valve
valve
assembly.
and stem.
Okay. So body, valve, port, stem, and pressure relief devices. What are the materials out of which the cylinders are made? And why those?
molybdenum. Sir.
Molybdenum
The
alloys.
molybdenum steel. Okay, it is a combination of steel with chromium. Okay, molybdenum is one material plus steel with chromium may be added, but an alloy of this molybdenum and chrome also may be used, and they are used to minimize the weight and wall thickness. And any other important feature that you can see, this is the body, this is the neck. Do you find any joint here?
No,
Is it,
sir.
so what is that called? That manufacturing of a body is the neck without any soldering or any joining separately. What is that called? It's called seamless manufacturing. There is no separate joint. It's a single block. Okay, so the whole thing is as a die like this, and over which the cylinder material is poured, and it comes as a single unit without any soldering or any joining here. So that is the reason why there is no chance for them to explode. There is no gap to leak also. Okay, so this is called seamless cylinder, SEAM. There is no attachment. And of course, I showed you the earlier picture, the conical depression, the rupture and all that, that's a repetition. So just go through that. What is pin index safety system? So this is the picture, how to show you how it will be attached. The cylinder will get attached the pin in the hanger yoke assembly, how they will enter. And there are sometimes the questions are asked, mention the pin index for common gases used, that you should be able to know. Of course, air is 1 to 5, carbon dioxide, of course, not commonly used, but the oxygen and nitrous oxide you should know. 3, 5, 2, 5, 1, 5. These are the three things which are commonly used in our machine. So oxygen is 2, 5, nitrous oxide is 3, 5, and air is 1, 5. Okay, remember that very clearly. No, don't make any mistakes. Of course, all these cyclopropane, ethylene are all obsolete. They are not used, but if you do very well, they may ask you, but they all have different pin index. What are the dimensions of the pins? Sometimes some cranky examiner wants to know what exactly the dimensions of the pins. Any idea? So they are 4 millimeter in diameter and 6 millimeter in length. Okay. So the pin which is projecting from the hanger yoke assembly, that is 4 millimeter diameter, 6 millimeter in length. And what is the pin index for Entonox and what is the length of the pin? Entonox is always said it is number 7. Okay, and the pin is 7 millimeter. So it is a single pin, and it is called the 7th position. So single pin and a 7 millimeter long for Entonox. When was the pin index system incorporated in anesthesia machine, and what are its features? Which year they incorporated it?
No ideas.
1952. Okay, it was incorporated in 52, and it is a safety mechanism so that you cannot interchange cylinders. Okay, and each cylinder has a 2 pins on the yoke positioned to fit into the holes of the valve block, and the port will seal only with proper alignment of the pins and holes, which are of 4 millimeter in diameter and 6 millimeter, and pin 7 slightly larger for the 7th pole position for Entanox. And 6 pin positions are located at interval of 12 degrees with the pin 7 located at the position between 3 and 4. Okay, these are all some of the points which may be asked if you are doing very well in the exam. So try to remember. What is the color coding for different gas cylinders?
For oxygen,
What
White
we
and
have is slightly different from international color coding.
International.
Okay, international color coding for oxygen is
gray with
green color.
green.
gray
It is
body.
only green. Okay, whereas for we are using black with white shoulders for oxygen, whereas the international color coding is green. Okay, and nitrous oxide is French blue. It is not called blue, it is called French blue, and carbon dioxide is gray, and so white shoulder, black body for oxygen, light blue, actually it will be called French blue. Medical air is black and white, what you see here, and suction yellow, nitrogen is black, and carbon dioxide gray, and helium is brown. So these are all the different color coding. What are the functions of check valve assembly, which is which prevents the gas from allows the gas to go in one direction only. Okay, this is the check valve assembly. When you fix a cylinder, the flow should be only from the cylinder into the machine. It should not be on the reverse direction. So for that there is a check valve. So whenever there is a high pressure mounting on the pressure regulator side, it cannot come back to the cylinder because the valve will be obstructing that. So these are the safety devices. Safety device in the yoke is called Woods alloy. This is another common question they may ask you. I showed you the pressure which can be easily let out if there is a high pressure mounting, and that screw is made out of what is material called wood alloy, which is a fusible plug made out of bismuth, lead, cadmium, and tin, and it melts at temperature of 150 to 170 degrees Fahrenheit and prevents explosion. Or it may be in the form of what is called copper frangible disc, which are the names that you have to remember. So Woods alloy you remember because one examiner is very fond of asking this particular material as a safety measure in the yoke assembly. Now what is shown here?
Nitrous oxide cylinder.
E-type nitrous oxide cylinder. One must always say the size of the cylinder also. Okay. E-type. Name 4 people involved in the production, identification, action, and using of this clinical purpose. Some amount of history. Who identified? So Joseph Priestley in 1772. He was the person who first identified this. And Humphrey Davy developed on that. Horace Wells is the person who used it and failed to demonstrate that it has some effect. Okay, but later on, he was actually, many of these inhalation agents were used by dentists for dental extraction. So Horace Wells also is one of the person who was a dental surgeon who used it, and then Gardner Quincy Colton. He was another person. You can see the years 72, 79, 45, and 60. So gradually the usage has been improved by these various persons. So how nitrous oxide is able to provide analgesia? What is the mechanism of pharmacology? All of you know that nitrous produces analgesia, and we are using it in labor analgesia also as Entanox. But what is the mechanism by which it provides analgesia? By acting on opioid receptors, NMDA receptor antagonism, modulation of endorphins and enkephalins, and also activates supraspinal inhibitory pathways. So there are 4 mechanisms by which nitrous oxide provides the analgesia: activating the opioid receptors, NMDA antagonism, just like your ketamine, and modulation of endorphins and enkephalins. Probably this is the reason why it was used as a laughing gas. You know, it produces euphoria, and it was used as a party drug in those days. So the mechanism probably is through this. Just like your ketamine, it produces some hallucination and euphoria and all those things. And modulation of endorphins and enkephalins and activation of supraspinal inhibitory pathways. What is pointing effect? Where is it involved, this pointing effect?
When
In
two
N
gases of different critical temperature mixed in a single cylinder, the gas with the higher critical temperature will have a pseudo low critical temperature.
See, pointing effect is, when will it happen? When you have one gas in a liquid form and another gas in a gaseous form. Okay. So if you pass the gaseous oxygen into the liquid nitrous oxide, then what will happen? The nitrous oxide also will turn into a gas. That is what is called pointing effect. Okay. So you have two different forms of gases. One, nitrous oxide is in the liquid form. Oxygen is in the gaseous form. So when you pass the gaseous oxygen into the liquid nitrous oxide, the liquid nitrous oxide also is vaporized to turn into a gaseous form and mix with that oxygen. That is called the pointing effect. So refers to bubbling of oxygen through liquid nitrous oxide, resulting in vapor formation of liquid nitrous oxide, causing a mixture of oxygen and nitrous oxide. Okay, that is the answer that you have to give. And compare the properties of oxygen, nitrous oxide, and air cylinders. Of course, this is the comparison. You have the cylinder content, oxygen 625 and nitrous oxide 1590, because it is a liquid turning into vapor, and air will be also 625. Cylinder weight empty, all of them are same, because E-type cylinders, the tire weight, empty weight will be the same. Cylinder weight when it is full, for oxygen it is 6.76. So 5.90 to 6.76. Nitrous oxide is heavier, 8.80, and air we do not know. It will be more or less slightly different. And cylinder pressure, full cylinder pressure for oxygen it is 2000 psi. For nitrous it is 750, and medical air gas is 1800. What you get for your day-to-day use is almost close to oxygen level. Okay, only nitrous oxide is the full pressure cylinder is 750, because it is partly in liquid form and it is only the vapor which is causing the pressure. Now, what is being shown here? So once you read about nitrous oxide, or once you are given a cylinder of nitrous oxide, you should be prepared to answer about the combination of oxygen nitrous oxide. So this is everything is written here, 50% oxygen and 50% nitrous oxide. It is called the Entanox. Why it is called Entanox? No, how this name is derived? Something like your numerology, when you write your name, you know, when you want to write Rama, you can put R-A-M-A or R-A-A-M-A. So like, just like that, E-N-T, Ent is N2O, N2O oxygen. So that is the English alphabetical form of writing N2O, N2O, ox. Okay, so Entanox. It's cylinder dispensing unit. What is unique about its valve? It has a valve, delivery valve here, and this is the hose which goes to the patient. This is the mask which patient has to keep in the face and self-administer this gas during labor analgesia. And anything special about this mask, or the valve rather? This is called the demand valve. Okay, only when the patient takes an inspiration, this valve will open and deliver the gas. Otherwise, it will be sealed. So this is called the demand valve, which will open when inspiration occurs, creating a negative pressure. What is pointing effect? Of course, we have seen that it's a phenomena where the oxygen bubble through nitrous oxide. Then there is another phenomena in this Entanox. It's called lamination. What is lamination of in Entanox cylinder and what is its significance?
No idea.
No idea. Okay. When Entanox cylinder is cooled below its pseudo-critical temperature, nitrous oxide will again become a liquid and settle at the bottom with gaseous oxygen at the top. Okay. So you manufacture Entanox at a particular temperature, and the cylinder is stored in a very cold climate. Then what will happen? The nitrous oxide will again liquefy, and once the liquid is formed, it will go to the bottom, and the top will be filled with oxygen because the oxygen is a gas. It can never become a liquid. So when the patient starts inhaling this mixture, he will receive or she will receive only oxygen in the beginning. Later on, this nitrous oxide, which is in the liquid form, will become a vapor and travel along with that. At that time, the oxygen content will not be 50%. It will be much less because most of the oxygen is used up, and the nitrous oxide will be 80% or 90%. So patient will receive a very high hypoxic mixture. So this is called the lamination. It becomes a layer of liquid at the bottom and gas at the top. Okay. So because the patient will inhale pure oxygen initially and high hypoxic nitrous oxide later. So what should you do to prevent that? The question is how to prevent this effect due to lamination.
We have to store it 24 hours prior to use at 4 degrees Celsius.
Supposing somebody has kept it in the cold and you have to need it immediately, what can you do? Quick remedy. By inverting the cylinder several times or warming the cylinder before use. Very easy. Okay, you can just warm the cylinder or you can make it upside down several times. Twist it this way and that way. It will mix and it will form a vapor. So mention some uses of Entanox. All of you know that it is being used in Western countries for labor analgesia even today. But to my knowledge, it is not available in our hospitals here. Any other uses of Entanox apart from labor analgesia? Burns dressing also you can use it. Okay, and in field anesthesia, whenever there is a mass casualty and you want to extricate people from debris of collapsed buildings or railway accidents and all that, to prevent them from suffering from pain when they are being extricated from debris, you can use that. Okay, so these are the uses of Entanox. What is filling ratio and why it is important? This is another common question with regard to the cylinders.
It is the amount of gas to be filled with water the cylinder can hold.
So what is the filling ratio for oxygen?
Point.
It's a very, very basic question. The filling ratio is the density percent ratio of weight of the gas in the cylinder to the weight of the water that the cylinder can hold at 60 degrees Fahrenheit. Okay. So it is compared with the weight of water which is filled in the cylinder to, so it is applicable only to gases which become liquid, not to gases. So there is no filling ratio for oxygen or air. So if the examiner asks you what is the filling ratio of oxygen or air, don't fall a prey to that. You can say there is no filling ratio because only the liquid agents which become a gas, they have to be filled carefully. Otherwise, they will expand too much and there is a chance for explosion. Okay. So filling ratio is for liquid gases only, liquid agents which are compressible. So 68% is the value, that is you can fill only up to 68% of the capacity of the cylinder for nitrous oxide and carbon dioxide. So that even if the temperature exceeds 60 degrees Fahrenheit, the expansion will be still held within the cylinder and it will not cause an explosion. Okay? And the common tests that are done to see whether the cylinder is still usable or not, because they are filling with high pressures. So what are all the common tests that are done to the cylinders?
Hydraulic test, bend test.
Tensile
Tensile
stress,
stress.
flattening test, bend test, impact test, all. These are some of the names you should know. And they are carried out 1 out of every 100 cylinders, and every quarter 1 cylinder will be tested. Okay. And these things will be printed on the cylinder neck, or the junction between the neck and the body. Okay. So you can sometimes see that. Now you see another picture where the hanger yoke assembly, instead of the cylinder, there is something which is fitted here. What is that? This is the hanger yoke assembly which we have been talking about all this time. Instead of cylinder, there is something else which is fitted into that, and this is the retaining screw which has been tightened here. What is this portion? And why it is being done? This is called the blank or dummy plug. Okay, so it will prevent the nipple through which the gases are going to enter. If you keep it open, some dust or oil particle may go and deposit there. So to prevent that, you are supposed to keep the hanger yoke assembly closed with the blank plug to prevent oil or dust getting deposited at the nipple, which is the entry point for the gases. Okay, so this is one of the things that may be there. And when can a wrong cylinder be placed in the yoke?
More
Despite
than one board seal is.
You can have more than one board seal, and you can tighten it and prevent a leak. Very good. Anything else? If the pins are broken or the holes are too long, then also you can fix a wrong cylinder. So wrong cylinder may be placed with 2 washers or board seal. Pins on the yoke are broken, or holes in the cylinder are too deep, then you can place a wrong cylinder also. Now what is shown here, and who is the inventor of this? This is in connection with the respiratory medicine only. Of course, I'm not seeing the full lateral view also, but can you just by the face of this dial, can you identify? Okay, this is called the Wright's respirometer,
Pyrometer.
designed by Dr. Basil Martin Wright. Okay, what are the parts of this? By looking at this, can you just describe what are all you are seeing?
It has 2 values, sir. One is in liters and
So you have a dial which is marked with a inside there is a smaller circle, outside there is a bigger circle. Okay, and it is written liters here. So the outer circle is divided into 10, 15, 20, 25 like that, in larger numbers of liters. And there is a pointer for that. And the inner circle is marked in 0.1, 0.2. That means 100 ml, 200 ml, up to a maximum of 1 liter. Okay. So there are 2 markings. So it has an inlet port, which is this portion. And there will be outlet port on the back, and vanes are there to make the air that is rotated, and the dial with one outer circle calibrated at intervals of 10 liters and an inner circle with interval of 100 ml. And there are 2 buttons here. You can see this button once there and this button. One is called the stop or start button. Another is the reset button. To bring both the needles to 0, you have to press one button, then both of them will come to 0. Then you place the machine on the patient's face, press the start button, then patient will start breathing through that. So what are all the measurements you can make using this? This is more or less like an Osce question. I incorporated it because it is combining with it can be used in the anesthesia machine also to measure the tidal volume.
maximum breathing capacity.
maximum breathing capacity. Inspiratory or expiratory tidal volume and vital capacity both can be measured using this instrument. Okay. And how it can be used? So there are two methods. Either you can attach a face mask like this and keep it onto the patient's face, or you can attach a breathing hose and ask the patient to keep the mouthpiece and blow through that. Name another instrument by the same person and its use. What other Wright's machine is there? This is called Wright's respirometer or Wright's spirometer. Any other Wright machine you know?
No, sir.
It's called Wright peak flow meter. Okay, so this is also another machine where you blow through this and you can measure the speed of which the gas comes. So what is this is used for? This is used for measuring tidal volume and vital capacity. What can you use this for?
Peak expiratory flow.
Peak expiratory flow can be measured, which is important for identifying what?
Bronchial asthma.
Obstructive and restrictive disease. Help to diagnose obstructive lung disease by measuring peak flow rate. Normal value for adult is 400 to 700 liters per minute. This is the speed, not the value actually. So this is the speed at which person should be able to blow out. And for children, it is 150 to 400 liters per minute. So two machines that are made, used by the same person is Wright's respirometer or spirometer and Wright's peak flow meter. What is critical temperature and critical pressure? This is another common physics question that will be asked.
So it is the temperature above which it cannot be present as a
The
liquid.
gas cannot be liquefied. Okay, the critical temperature of a substance is the temperature at and above which vapor of the substance cannot be liquefied, no matter how much pressure is applied. Okay, that is the critical pressure of a substance is that pressure required to liquefy a gas at its critical temperature. Okay, so that is called the critical pressure. What is medical air we are using nowadays in our anesthesia machine? What are all the characteristics of medical air? Is it different from the common air that we are inhaling every day?
Yes, sir.
It is little more
It is
purified.
devoid of
It has,
fluorides.
no detectable liquid hydrocarbons, less than 25 parts per million of gaseous hydrocarbon, and 1 micron size or greater than particulate matter, and no dew of less than 50 psi, and low levels of nitric oxide found in ambient air may be co-oxygenation in ventilated patients. Okay. How to calculate when you use both oxygen and air in your day-to-day practice? How do you know what is the percentage of oxygen you are delivering to the patient? Supposing you keep 2 liters of oxygen and 2 liters of air, what is the percentage of oxygen you are delivering to the patient? How do you calculate that? When we are using nitrous oxide, we know when we keep 2 liters of nitrous oxide and 1 liter of oxygen, we know we are giving 66% nitrous oxide and 33% because the total flow is 3 liters. Out of that, one part is oxygen and 2 parts is nitrous oxide. So we can easily calculate it is 2:1 ratio. So we know 66 into 33. Whereas when you use oxygen and air, the oxygen concentration you have to calculate using this formula. 100 into 1 into oxygen, how many liters of oxygen you are using, plus 21, and divided by total flow, oxygen in liters and air. So for example, if you are using 2 liters of oxygen and 2 liters of air, if you multiply 100 into 1 into 2, 0.21 into 2, that is air contains only 21% oxygen, whereas oxygen contains 100% oxygen. So for that you have to calculate that, and the total flow is 2 plus 2 is 4. So if you multiply all that, you are giving roughly 60.5% of oxygen in the total gas mixture. Okay. So sometimes they may ask you how to calculate that. And what is adiabatic and Joule-Thomson effect? This is another very frequently asked question on the cylinders. Adiabatic changes and Joule-Thomson effect are when a gas is subjected to sudden compression, the heat energy is produced rapidly, and when you release the compression, the reverse occurs and there is a sudden expansion. But there is no exchange of energy with the surroundings. That is called the adiabatic change. That is, no energy is released or gained, but there is a difference in the pressure. So if there is a change in the energy, every time you compress and release, there should be an explosion. Okay. So this is prevented in gas cylinders, and that is called the adiabatic change. And in Joule-Thomson effect, when the gas is allowed to escape through a narrow opening, there is a sudden drop in temperature, which will cool the air that is surrounding the gas cylinder. So what will happen? The water vapor in the gas cylinder will condense into water droplets, and that will get deposited. That you can see sometimes when you use the nitrous oxide cylinder. You will see after some time there will be ice formation on the nitrous oxide neck and valve portion. That is because of what is called the Joule-Thomson effect. So these two are the common effects. So you can remember that when there is a sudden compression and release, there is no energy exchange. To say that the answer for adiabatic change is okay. And Joule-Thomson, when there is a sudden release of a compressed gas, there is a drop in temperature. These are the 2 points you have to remember. Now, what is shown in this picture? This is a common, another very frequently asked machine question in the exam. What are you seeing?
It's a cylinder pressure gauge.
It's a pressure gauge for oxygen. Okay,
Oxygen
so pressure
cylinder.
gauge for oxygen is seen there, and you can see there is a partly emptied cylinder. It is half full. You can see the marking is there, and there is a cautioning to say refill or the gas content is very low, and the outer one is showing the pressure in psi 500, 1000, 1500. And open cylinder valve slowly, use no oil, all precautions are there. So they may ask you what are all the safety features in this oxygen pressure gauge. That's the commonly asked questions in the examination.
It is color coded.
Color coded. There is
Name
no
is
color.
written.
It's white in color. Okay. Name
And
is
so-
written.
yes.
Okay. So this
If
is
at all
oxygen pressure.
it ruptures, it will explode in the posterior back side to prevent
Okay.
damage to the
Person. Okay. So and also the earlier machines used to have a straight pressure gauge like this. Nowadays they have an angulation. Okay, so there is a bend, and the pressure gauge is in an angulated form. That is the reason why even if it ruptures, it will blow out on the back side and not on the front side. Okay, and pressure is displayed, name is written, use no oil, cautions are given, refill. All these are considered as safety mechanisms or safety features. And this is the working principle of a Borden pressure gauge. So what happens when the gas is entering at a high pressure here, this Borden tube becomes straight. So what is curved like this becomes straight, and there is a pointer attached which will move along with as the pressure is showing. And as the pressure decreases, the pointer will return back to its original position, showing the exact level of the gas inside. So the safety features are gauge is color coded, name and symbol of the gas written over the dial, Borden tube ruptures, it is vented from backside, gauges are angled and placed in such a way that it can be easily read, and instructions like use no oil and open valve slowly are written on the gauge. These are all the things which you are supposed to say if they are present in that machine. And this is the toy that most of you would have seen or used as a child. This is called any name for this? When you blow through this will straighten out. What is rolled? This color paper will roll out and it will make a noise. So children used to love this when they go to Trivura and other things. You can see everybody blowing this, making quang, quang, quang noise like that. Okay? So this is called the blow out noise maker or party horn. Okay, so this is the same principle that is used. When you blow with a high pressure, this tube straightens out. So the same pressure and the same principle is only used in that. And this is the person, some history. Can you name the person who designed this? What we saw the pressure gauge?
Ritchie Vishal.
Eugene Borden. Okay, his name is Eugene. He only designed the Borden pressure gauge. And this is the nitrous oxide cylinder. What is the difference in using an oxygen cylinder and pressure gauge and nitrous oxide pressure gauge?
Sir, the pressure
Really
shown in the
necessary?
nitrous is not reliable.
Because it will show the same reading till the last drop of nitrous oxide, liquid nitrous oxide evaporates. So actually there is no use for this pressure gauge, because once you open a full cylinder, it will show 750 psi or 7.5 pascals or whatever you want to know. But till the last drop is there, it will be showing the same value. Then why they have incorporated this in the current machines? Earlier machines, they never had this pressure gauge. The reason why they incorporated it is because when you do neurosurgery or cardiac surgery, there is very little time to realize that nitrous oxide, when it is used as one of the major inhalation anesthetic agents, there is little time to realize that the cylinder has become empty, so that you can switch over to the new machine. During that time, because of lack of nitrous oxide, patients' anesthesia became light. So lighter patient in a neurosurgery and cardiac surgery, you can understand what will be the repercussions of that. So in order to make sure that you can replace or open a new cylinder, and within the time that the cylinder becomes totally empty, they incorporated it. Okay, and not for the normal regular general surgical features. It is incorporated mainly for the cardiac and neurosurgical procedures. But nowadays, even this may become obsolete, because nowadays we are slowly weaning off from using nitrous oxide and we are going into combination of oxygen and air. Now this is what are the features in the pipeline inlet connections that are going to the back of the machine. The hoses are connected here, nitrous oxide, oxygen. So what features are there? Is the entry point for gases from pipelines. It is mandatory for nitrous oxide, oxygen, and also for air and suction also. The inlet should be non-interchangeable, and they are nowadays used with what is called diameter index safety system instead of the pin index system that is used in the olden days. Nowadays it is all what is called diameter index safety system, and each inlet must contain a check valve to prevent reverse flow, and it should have a filter to prevent any particulate matter entering. And pressure indicators for that should be between 50 to 55 psi. So the pipeline pressure is always reduced at a manifold level itself, and it comes at a 50 to 55 psi pressure. And if a cylinder valve is open and pipeline supply fails, there will be no change in the indicator pressure till the cylinder is nearly empty. So that is why you should always keep the spare cylinder valve closed whenever you are using a central pipeline supply. You should not keep the cylinder valve open until the pipeline pressure drops and you see that or an alarm is given. Then only you should open the spare cylinder that is in the machine. Pressure regulators, why pressure regulators are needed in anesthesia machines?
To avoid barotrauma and to avoid damage
Barotrauma.
to the flow meter.
Machine also, okay, flow meter. So to maintain constant flow for a changing supply, pressure regulators are needed, and it also reduces the high and variable pressures in the cylinder, and also prevents barotrauma. Okay, what is the physical principle, working principle of the pressure regulator? This is the high pressure coming into a smaller area is delivered into a larger area. Okay, so high pressure coming into a smaller area is small. So the P is capital P, high pressure. Area is small a. It is released into a larger area, capital A. Automatically the pressure drops and becomes a smaller pressure. You can see the small p here. So that is the basic principle that you can remember. So high pressure delivered into a small area gets released into a larger area to allow the pressure to drop. And to keep the pressure at the desired level, this screw is used and a spring which moves the diaphragm to adjust the size of the larger area. So what will happen if you pull the diaphragm here? What will happen? Pressure will decrease or increase? Supposing this is the diaphragm, this dark line you are seeing is the diaphragm. Supposing I push the diaphragm to this position here, what will happen to the pressure?
Decreases.
Decrease, because the area is increasing further. Okay. On the contrary, if I want to increase the pressure, I will have to bring the diaphragm downwards so that the area becomes less. Then the pressure will become increased. Okay. So that simple pressure, which is the Pascal's law, that is how it is the principle that is made. A larger pressure acting over a small area is balanced by a smaller pressure acting over a larger area. And why pressure regulators are also called preset regulators? Because they reduce it to the 50 psi, standard 50 psi. 50 to 60 psi is the standard pressure. So that is also called the predetermined or preset pressure. Why cylinders fitted to the machine be kept closed when not in use? That's the reason I have already told you. Cylinders should be kept closed routinely. Otherwise, if the valve gas fails, the machine will automatically switch to the cylinder supply without the anesthetist being aware that the valve supply has failed until the cylinder is also empty. Okay, so that is the reason why you keep the cylinders always closed. And once the valve supply starts dwindling, the oxygen failure alarm will start because the pressure drops, and you will open the cylinder. Then only you should open the cylinder. Okay, so that is that's one of the questions they may ask you in the exam. What are the features of oxygen flush valve? This is another common question in the examination. What is the purpose of this oxygen flush valve and what are the features? When will you use the oxygen flush? Is it to be used at all?
When there is a leak,
Ah.
when we not able to ventilate
Hmm.
during difficult airway situation, we can use oxygen flush.
Oxygen flush. Okay. So how much of oxygen will be delivered and at what pressure it will be delivered when you activate that?
35 to 75 liters.
35 to 75 liters per minute.
At what pressure? At the pipeline pressure. Okay. So receives oxygen from pipeline inlet or cylinder pressure regulator directly. Directs high unmetered flow to the common gas outlet. The machine standard requires that the flow will be about 35 to 75 liters per minute. Single purpose self-closing device designed to minimize unintentional activation labeled oxygen plus. Hazards are it may cause barotrauma because it is coming at the high pressure without getting reduced like your other lines. So it will be at more than 20 psi. And it may cause dilution of the inhaled anesthetic, and the accidental activation may cause barotrauma. and it may cause internal leakage, or flush may get stuck, and slowly oxygen may be leaking out. Okay? And flush valves for other gases other than oxygen are not permitted in anesthesia machine, and it may be activated to machine be turned, not necessary that it should be turned on. It can work even without the machine being, and the pressure delivered is 60 psi. So that is the high pressure that is coming. So we had one case of surgical emphysema when we had to use oxygen flush for ventilating a patient, a young lady coming for a thyroid surgery, and we couldn't intubate at the first attempt, so we were using oxygen flush. Within no time, we could see a lot of gas going under the neck and chest, and the whole body, whole upper part of the body was swollen. So such amount of leak, temporary trauma can happen because of the high pressure. So these two values you have to remember. The oxygen delivered is 35 to 75 liters per minute at a PSI of 60 PSI. Okay. Now you are seeing two oxygen flush activating switches. What is the difference between the two? This is in one machine, this is a newer machine. This is older machine, this is newer machine. Both are showing this is the oxygen plus, which is the indicator for the oxygen flush activator. Can you see any difference in this?
So different shape and different color code,
Ah.
and one is kept in the depression with the rim protection.
This is the protecting guard, okay, so that it will not be activated accidentally. Just like the guard that you saw for the flow meter knobs in the earlier picture, here there is no guard. Any slight movement, it can depress the switch. Whereas here, there is a depression already and there is a guard here, so it cannot be activated. Now, where is the oxygen flush in this machine? This is an older type of machine. So if they keep this machine in your Viva exam, they may ask you where is the oxygen flush. Can you identify the oxygen flush in this machine?
No, sir.
No, okay. So can see this is very close to that. This is the off position for the oxygen flush. When you turn it down, it will activate the oxygen. And this is the circuit selector in the older machine. This is the common gas outlet. So this portion, I have made it zoomed out so that you can see that. Can you see this knob? So this is the switch for oxygen flush in the older machine. Okay. How to calculate the amount of gas in nitrous oxide cylinder?
Avogadro, using Avogadro.
Avogadro's hypothesis. Okay, so what is Avogadro's hypothesis? 1 gram molecular weight of a substance will occupy 22.4 liters at standard temperature and pressure. This is Avogadro's hypothesis. So if you say the weight of cylinder of nitrous oxide, empty weight is 5.6. I mean, empty weight is 4.5 and the full weight is 5.6. Then there is a weight of nitrous oxide in the cylinder is 1.1. Okay, 44 is the molecular weight of nitrous oxide, and it should occupy 22.4 liters. And the amount of oxygen, I mean nitrous oxide you have is 1.1 kg, which is about 1100 grams. So 22.4 multiplied by 1100 divided by 44 grams, get 560 liters. And if you use 2 liters of nitrous oxide per minute, a cylinder should last about 280 minutes or 4.6. And how to calculate the volume of full cylinder in a B-type oxygen cylinder? Boyle's law is used. So for nitrous oxide, Avogadro's hypothesis is used. For Boyle's law for oxygen. So that oxygen, Boyle's law says pressure into volume is equal to P2 into V2. P1 into V1 is P2 into V2. So the pressure inside a full cylinder is 2000 psi and the volume is 5 liters. And you have to reduce it to pressure of 15. So what will be the volume? So if you make a calculation like that, you get 665. So if you use 3 liters of oxygen, the full cylinder should last for 220 minutes. So these are some of the calculations. At least remember that for calculating the amount of oxygen left in the cylinder, you use Boyle's law. For nitrous oxide, you use Avogadro's hypothesis. And the duration, of course, they can ask you, you start with this pressure, how much you should do, how long the cylinder will last. All this is a common question that you have to remember. Now coming to the flow meter tubes, I am showing you pictures of 2 flow meters. So what is shown here? You can see this is a milliliters, starting from 100 to 1000 maximum. Whereas here 1 liter, 2 liter, 3 liter up to maximum of. So this is a what type of flow tube?
Twin tube flow.
Twin tube flow meter for both the low flow as well as high flow. Whereas here what is, it is starting with 0.4, goes to 1 in the bottom, and immediately jumps to 2, 3 and all goes up. So what is this called?
Single tube
It's
flow
a
meter.
single flow meter, but what is the tapering? Is it same or different? Here it is gradually enlarging. Here it is partly smaller, then suddenly becomes, okay. So that
Yes.
is called tapering. So this is a 2 tube design. The A, B is the dual taper. This bottom is a normal small tapering. Suddenly it becomes bigger tapering. So this is called the dual taper design. And what is the flow meter tube made up of? Called, and what is the material out of which it goes to?
Torque tube.
Torque tube. Okay. And the material is borosilicate glass. Okay. What is the purpose of single and double tube taper tubes, which we have already seen? It is for separate flow meters for low flow and high flow. And the same gas when the tubes are single tapered. If it is blowing through the 2 tubes, then it is a double tube tapering, mainly for low flow. So how does the bobbin rotate when the gas flows? All of you would have noticed that when you open the gas, the bobbin is rotating all the time. And the common question they may ask is, when will not the bobbin rotate? What are the causes that the bobbin may not rotate sometimes?
If it sticks with the tube.
Why does it get stuck? That is the reason. If it gets stuck, it won't rotate, correct. But what is the reason for the bobbin to get stuck so that it cannot rotate? One is the tube may be slanting. The flow tube may be slanting so that bobbin is falling onto one side. Second is it may be dust may be there. Third, there may be static electricity. Okay, there's a thing called static electricity which will attract the bobbin to the side. These are the 3 reasons. One, the flow meter tube may be slanting or tilted. Second, there may be dust particles which may be attracting that bobbin. Third is static electricity causing this sticking. And the bobbin rotates because there are slots present at the top. You can see these are the grooves which are there, which when the gas goes, they rotate thing. So there are 4 different types are given, and sometimes they may ask you the names. One is called the ball type, and if it is a ball type, the gas flow is calculated from the center. Whereas if it is a non-rotating type or a skirted and non-skirted bobbins like this, where do you read the gas flow? At the bottom or the top?
Tops.
It should be always be read at the top, okay, not at the bottom. Okay, so that is also another question that is commonly asked. Where do you read the gas flow value? That is at the top of the bobbin. Now, something which is present in the newer machine is being shown here. Carefully watch. And what is this portion mainly?
It's auxiliary oxygen.
Auxiliary.
Oxygen
Air.
port with flow meters, air and oxygen.
There are 2 both for air and oxygen. You have a flow,
Separate
auxiliary flow
oxygen.
tubes with an outlet. Okay, so it's formula. It is self-contained and a short tube with a maximum flow of 10 liters per minute, which will be usually on the left side of the machine. And it can be used to supply oxygen to patient without turning on the machine itself. The main power need not be switched on. It can work even without the main power being on. And older machines, it worked on the pipeline supply, but in the newer machine, even cylinder and pipeline both can supply oxygen or air through this. Now you are seeing something different here. Can you see what is being done here? You have a oxygen flow meter here, which is connected to the common gas outlet, and oxygen has been opened. I mean, oxygen is kept open. So what is this being done for? Any idea? Supposing you open the oxygen here to say 3 liters, what should happen to this flow meter? Now, what should it read? So now the oxygen is getting delivered to this flow meter from this outlet. I am opening the cylinder to deliver 3 liters of oxygen from the machine. So what should be the reading in the, and I open this valve also for this to deliver. What should be the reading here? Are you able to understand my question? Now the
Same
oxygen
liters will
source for this is the same from the machine. Huh?
We need to change.
it is the same flow.
You should get the same 3 liters delivered here, isn't it?
Yes, sir.
And if it is not delivered 3 liters, it is showing only 1 liter or 2 liters. What does it mean?
There is a leak in the
Internal leak. Okay, so this is flow meter connected to the common gas outlet to quantify the internal leak. Okay, so this is one of the methods of identifying the internal leak. So you can connect the common gas outlet with a tubing to the regular flow meter and open the gas here. Whatever amount of gas flow happens in the flow meter here should be reflected here. Otherwise, it indicates some leak inside the pipelines. And the third one is what is transitional hybrid flow meter? That is because of the newer thing. So here, if you see, what is the difference you are seeing in this flow meter assembly? It is a combination, mechanically controlled with a needle valve. You can see all the knobs are here, but the display is electronically displayed. Okay, so bar graph on the computer screen. So there is needle valve, so flow can be generated even without electric power. That is the reason for this transitional hybrid flow meter. Flows captured and displayed electronically. So the electronic flow meters allow automated anesthesia record keepers to chart fresh gas flows. So these are some of the newer things that are developing. Now comes important safety feature. This is called Link 25 system. What is it used for? What is the purpose of this?
It is the relation between the pressure of oxygen and nitrous. If the oxygen supply goes less than 25%, then the nitrous flow will be shut off.
So it is a measure to avoid delivery of a hypoxic gas mixture. It ensures all the time that a minimum of 25% of oxygen is there in the total flow. Okay, so that there is no supply of hypoxic mixture. Nitrous oxide cannot increase without supplying at least minimum 25% in this. Okay, that is done by applying. There is a two sprocketed wheels which are connected by a chain. Okay, and you find this is a larger wheel and this is a smaller wheel. So hypoxic mixture is prevented by anesthesia machine by 3 mechanisms. One is what is called mandatory minimum oxygen flow. where 50 to 250 ml of oxygen will start flowing once you start the machine, even without opening the oxygen flow meter. Then minimum oxygen ratio will be maintained, and mechanical linkage like link 25 system, where there is a 14 tooth sprocket on nitrous oxide and a 29 tooth sprocket on oxygen. So the flow control will be always applying 25%. So remember these three names which prevent the hypoxia: minimum mandatory flow oxygen, minimum oxygen ratio, and link 25 system. Okay, this is another last method is oxygen ratio monitor control. Instead of using this chain and sprocket, you have resistive flow tubes which will adjust the pressure and allow the gas always to deliver 25%. So this is another modification of the same hypoxic mixture prevention. So instead of using the chain and sprocket, it is using what is called the resistive flow tubes. Now, what is shown here?
Inspiratory valve and the expiratory valve.
Unidirectional valve. Okay, unidirectional or check valve, which is present usually in the circle system attachment. What is seen here?
Pressure relief.
Pressure AP. This is the pressure release valve in the some of the older machines. Okay, so it is also called the pop-off valve, and it may be attached downstream of the vaporizer on the back bar. The older machines. I am showing all this because you will not be used to seeing all these things, having been used to your workstation all these years. So these are all, at least by pictures, you should be able to remember, because most of the hospitals will keep some old machines also for you to get confused. So this is at least picture you should remember. They are called pop-off valve, and they prevent high pressure being transmitted to the machine. Whenever preset pressure is exceeded, valve will open automatically and gas will be vented out. And the pressure which will be exceeded is 35 kilopascals. So this valve limits the machine to provide, and if this valve is there, you cannot provide jet ventilation. When you want to use bronchoscopy, you cannot use a jet ventilator because you require a higher pressure for jet ventilation. Once the machine pressure exceeds 35 kilopascals, it will automatically vent out, so delivery will not be happening. What is this? What are the things that you are seeing?
Oxygen flush, common gas outlet, master switch.
This is not master switch. You can see
Switch
here.
between.
This is a circuit selector. It's called the circuit selector. That is the reason why I put this picture, because it may be confusing like master switch itself. Whereas here you have the things written. So to select between the open circuit and the closed circuit, this is the circuit selector switch. So oxygen flush guard, circuit selection knob, and common gas outlet. What are the features of common gas outlet? What are the common things that you have to see in the common gas outlet? Yeah, they receive all the gases and vapors from the machine and delivers to the mixture to the breathing system. And some of them have 15 millimeter female slip joint fitting into a 22 millimeter male connector. And machine standard mandate, it is difficult to accidentally disengage the delivery hose from the outlet. And the pressure delivered at the outlet is usually 5 to 8 psi. Okay, that is the pressure at which it will be delivered. This is again a very old machine. This is the back bar. What is seen here from right from here to here is the back bar. So what is the role of the back bar? What are all the things it is holding?
Flow meter, vaporizer.
Vaporizers, and circuit selector, oxygen flush. All these things are there. Okay. So this is part of the frame of Boyle's machine. It supports the rotometer or the flow meter, vaporizer, and other accessories. And there are two metal rods in the back bar. Flow meters and vaporizers are connected with each other and then bolted to the back bar. The flow meter assembly here shown as a 3 tube flow meters. One has been dummied. The carbon dioxide has been dummied, and you have another extra orange color. What is this now?
Cyclopropane.
Cyclopropane. It was used in the olden days. Okay, so oxygen, nitrous oxide, and cyclopropane, and this carbon dioxide flow meter has been dummied here, and one flow tube which is made dummy for probably carbon dioxide. And compared to the older machines where you have two vaporizers, here you have two vaporizers attached. What is the difference between these two? Supposing I want to use ether and trilene at the same time, can I use it?
Yes, sir.
Yes, we can use it because I have to just lift this lever here, lift this lever here, then I can deliver ether as well as nitrous oxide. I mean ethylene, trilene, trichloroethylene. Both can be delivered at the same time. Only time I cannot deliver trichloroethylene here is when I rotate this switch from open to close, semi-open to closed circuit. You know the reason why? That is when I turn this switch here. Are you seeing this? My pointer there.
Yes, sir.
Now this is in semi-open. If I turn this, I cannot lift this lever. This will not go up. So trilene is prevented from entering the closed circuit with soda lime. What is the reason?
It will nerve toxicity, neurotoxicity.
The metabolic product of trichloroethylene with soda lime is a very dangerous gas called phosgene. Phosgene, phosgene. Okay? That is a neurotoxin. So patients will go into deep coma if you use trichloroethylene along with soda lime. So in those days itself, they identify that risk. And so once you rotate this knob from open to closed circuit, this lever will automatically get locked. So this rotating knob is also called trilene lock in those days. Okay, so this is one of the historical things that sometimes some examiner may be fond of asking you. But in the modern machines, what is the difference between these two vaporizers?
There's a selected tech property.
There is an interlocking system. You can use only one vaporizer at a time. You cannot use both at the same time. So there, the back bar, there is a interlocking system or a selected tech system where you cannot rotate the dial even if both the machines are used in the same machine. Okay. So shown are the vaporizers of sevoflurane and desflurane. They are interlocked so that they can be used only one at a time. What is the purpose is interlocking prevents two agents simultaneously being used. It may result in agent with a higher boiling point condensing and mixing with the one that is having a lower boiling point. Okay, that is the main reason for that. And the another older machines, they used to have the agent with a higher boiling point placed downstream to prevent the above problem of the lower boiling point agent condensing it. Okay. So I'm showing the dial. Which vaporizer dial I'm showing here? 1, 2, 3.
Desflurane.
Desflurane vaporizer. What is the first one showing? First picture.
It is open at 5% concentration.
It is on at 5% concentration. And the second one?
It is in the transport position.
It is in the transport or tilting position. Third one is?
Closed.
It's a closed or 0%. Okay. So 5 shows delivery at 5%. Dial in transport position, dial in off position with no vapor delivery. What are the features of desflurane vaporizer and why you need such a special equipment?
So it has a very low boiling temperature and high saturated
Boiling
vapor
point.
pressure. Boiling point and high
So
saturated.
it has a very high vapor pressure of 669 millimeters at 20 degrees centigrade and 757 at 22.8. So because of high vapor pressure, it acts like a gas blender rather than regular vaporizer. That is, no fresh gas enters the vaporizer. It requires electric power to heat the liquid to 39 degrees centigrade. And vaporizer can be filled while in use also. There is no need to switch off the vaporizer because no fresh gas flow is entering directly from the flow meter. What is the method of filling the vaporizer called? This method, what you are showing here, what is it
Keep
called?
filling.
Keep filling.
Is it called key filling?
Yes, sir.
This is called easy fill method. Okay.
Quick fill.
The other methods are key funnel fill, key fill, quick fill, and of course easy fill is also one of the methods. What is the maximum percentage of vapor delivered by T6, that is the desflurane vaporizer?
18%, sir.
18%.
18%. Very good. So how are vaporizers classified? There are several classifications.
Based on the resistance, based on the temperature compensation, whether it is inside the circuit or outside the circuit,
The flow over or down.
depends
Okay,
upon
so,
the flow type.
Vaporization method first, which can be flow over, bubble through, or both, with or without wicks or injector type. Second is regulation of output, variable bypass or measured flow. The third is temperature compensation, either automatic or supplied heat or manual thermal compensation, no temperature compensation or electronic compensation. The fourth, agent specific or multiple agents. Five, whether it is a plenum or a draw over vaporizer. And sixth is the location, whether it is inside the circuit or outside the circuit. Okay, so 6 different classifications are there. So at least you must remember and say 3 or 4 in the exam. And give examples based on the classification. Of course, you have all the examples for that thirds of variable, ether, the common ether bottle, tech vaporizers are all a method of regulating variable bypass, measured flow. So we have all the examples there. And how to describe, so based on this classification, if a vaporizer is given, how you should describe them is concentrating, calibrated, plenum type, variable bypass, flow over with which temperature compensated, out of circuit. All the 6 you must be able to incorporate in your description if a vaporizer is shown to you and asked you to describe the features. So remember all the points to describe that. What is the difference between a gas and a vapor? This is one of the basic questions they will be asking if they give you a vaporizer to describe. What is the difference between a gas and a vapor?
So vapor is a gas above the critical temp. Below.
Vapor is one which can be compressed into a liquid. A gas cannot be compressed at a normal pressure and temperature into a liquid. Simple answer, okay? Vapor is the gaseous form of substance that is normally a liquid at room temperature and is below its critical temperature. Gas is a substance that has no shape or volume, which occupies a space and above its critical temperature and cannot be compressed into a liquid. Okay. So what is saturated vapor pressure? These are all fundamental terminologies which you have to know with regard to vaporizers.
The
What is
pressure at
SVP?
which further vaporization will not happen. From the
It is
liquid
at
to gas
equilibrium.
will not happen.
The vapor and the liquid are in equilibrium at that particular temperature. That is what is called the, as liquid continues to evaporate into the space above, it forms the pressure of the vapor increases. A point of equilibrium is reached at which the rate of evaporation equals the condensation when the space becomes saturated. This pressure at this point is called the saturated vapor pressure. That is, the vapor and liquid are at equilibrium. What is the boiling point of a liquid?
When the saturated
temperature?
vapor pressure is equal to the atmospheric
Atmosphere,
pressure.
temperature at which the saturated vapor pressure is equal to atmospheric pressure. Okay. So the boiling point is the temperature at which the vapor pressure of a liquid equals the ambient pressure surrounding the liquid. So what will happen for a liquid at a higher ambience, for example, in a high altitude, where the pressure, will it boil faster or it will take a longer time?
Will take longer time to.
Ambient pressure is low in higher atmosphere. When you go to Ooty or Kodaikanal, the ambient pressure is lower there. So our definition is the vapor pressure should become equal to the atmospheric pressure.
Boils faster.
It will boil faster. Okay, that is why, for example, there is a liquid called ethyl chloride, whose boiling point is only 22. Okay,
Yes.
and if your room temperature is 30, 32, and you put the ethyl chloride in a bottle, what will be the pressure inside? Will be higher or lower? It will be higher. That is why
Higher.
it used to come out as a spray in those days. Okay, ethyl chloride used to be used for spray cryoanalgesia in the olden days. So boiling point, you have to remember the temperature at which vapor pressure equals the surrounding atmospheric pressure. Right. How to calculate vapor concentration using saturated vapor pressure and atmospheric pressure. It is a volatile anesthetic agent. When it becomes a vapor, is it possible to calculate the concentration using the atmospheric pressure and the saturated vapor pressure of that particular agent?
Saturated vapor pressure of particular agent divided by
Atmospheric pressure is the
into the
concentration. Excellent. So formula calculated for gas concentration is saturated vapor pressure divided by ambient pressure or atmospheric pressure. So the example is the saturated vapor pressure of the sevoflurane is 20.1 bar, and the atmospheric pressure at sea level at Chennai, it is 100 bars. So 20 divided by 100 into 100, it is almost 20%. So the common question they will ask you is, in the olden days, ether was used for open drop anesthesia. Can you use sevoflurane for open drop anesthesia?
No.
Yeah, I have given you the answer here already. What percentage you will get if you pour your sevoflurane in the common air, in the room air?
Boils 20%.
Get 20%, which is what is the percentage you are using in anesthesia machine maximum? For
Maximum
sevoflurane,
8%.
8% maximum. Okay, so 20% is almost 2.5 times. So you will be giving a very lethal dose, and that is the reason why you cannot use sevoflurane for open drop. Whereas ether is a very safe agent. Its maximum percentage you get is only about 2 to 3% or 4% maximum. That is why those days we used to say an average anesthetist with average skill cannot kill a patient with ether because of this safety margin. Okay, so this is the relationship between SVP and atmosphere. What is splitting ratio?
It is the percentage of flow which goes to the variable bypass chamber and the vaporizing chamber.
Vaporizing chamber, yes. It's the ratio by bypass to gas through the vaporizer is referred to as splitting ratio. What is latent heat of vaporization?
It is the heat provided by the molecules at the base to
Container.
maintain the
One,
constant vaporization.
the amount of heat that is needed to convert a unit mass of liquid substance into gaseous phase at constant temperature. Okay, that is called the amount of heat required to convert a unit mass of liquid into its gaseous form at a constant temperature is called the latent heat of vaporization. Name these mechanisms for phase filling What is Fraser's Sweatman pin safety is this one. Okay. So have you all seen isoflurane being filled with this in your OTs? So this is called the keyed filling system. Okay. You have a separate key like this, and easy fill for sevoflurane is this. Just like that, fit it into that. So this is the what are the safety advantages of tech vaporizers?
It is agent specific.
Hmm.
It has interlocking system.
Very good.
As a selected technique.
So it is interlocked to isolate vaporizer, clear indication of liquid level, non-spill reservoir with up to 180 degrees allowable tilt, key fill or pore fill systems prevent filling with an incorrect agent, and increased wick capacity. Okay. How to calculate the volume of liquid agent used? What is the formula to be used? For example, you use 2% sevoflurane for a duration of 3 hours.
The amount of oxygen, the amount of
Yeah,
fresh gas
fresh
flow
gas
into
flow.
3 into fresh gas.
Correct. Volume of liquid used is per hour can be calculated by the formula by Ferrenreth and Eisencraft. It was set dial percentage into fresh gas flow liters into 3. All these 3 things have to be taken into account. For example, if you use 2% sevoflurane at a fresh gas flow of 2 liters for a period of fresh gas flow, we multiply by 3, the total will be 12 ml per hour. That is how the calculation. So the 3 is a standard. It will vary depending on the fresh gas flow and the percentage that you use. So if you want to reduce the expenditure on sevoflurane, you have to go for a lower percentage in the dial and a lower fresh gas flow, and you can use reduce the quantum of sevoflurane that is being used. So how to calculate the amount of vapor formed by 1 ml of volatile agent?
Sir, using Avogadro's and the hypothesis.
Hypothesis, correct. So 22.4 liters, that is 22,400 ml plus multiplied by the density of the agent divided by the molecular weight, that will give the amount of vapor that will be formed by that. So the formula you have to remember is 22.4, which has to be in cc, density of the agent divided by the molecular weight of the agent. So for example, for sevoflurane, the density is 1.53 and molecular weight is 200. So making use of that, you will get 171.3 ml of vapor for every 1 ml of volatile agent. Again, coming back to the text 6, which is commonly kept in the exam, what is seen in this picture is a dust fluorine vaporizer. Okay. What way this is different from other vaporizers?
Electronic.
Again,
It's electronically driven vaporizer. It has
it
electronic
electricity.
temperature
It is
conversion.
electrically operated, electronically. It needs electric power, and fresh gas flow does not enter into, but vapor only is injected into the fresh gas flow. What is the temperature to which it's heated? Already we have discussed in the
39
37 degrees Celsius.
39 degree. What are the reasons for no output alarm in this? Here you have a various things which are displayed once you switch on. All of you would have seen. As soon as the power is switched on, all these signals will first come, displays will come, and then only you will get that. So no output alarm will come if the liquid in the sump is less than 20 ml, or if the unit is tilted for more than 10 seconds when in operation, or when the power supply is disrupted for more than 10 seconds and due to internal malfunction. What is the maximum percentage in dial setting? Already we have seen it is 18%.
18.
Okay, right. Mention the common properties of the inhalation agents used. Commonly we talk about the boiling point, saturated vapor pressure, the density. Okay, so these are all the properties. Just given the various agents here. So you must know the boiling point, must know the vapor pressure, blood gas partition coefficient, and oil gas partition coefficient, MAC, and metabolized, whether how much percentage is metabolized in the body. Okay, these are the common physical properties that they may be asking you. So desflurane has the highest vapor pressure, 669 millimeters of mercury. And the blood gas partition coefficient, what is the importance of this? And you see which one has got the lowest blood gas partition coefficient in this?
Xenons.
Desflurane.
Xenon. Yes, here it is xenon, and desflurane comes next. Then isoflurane. Nitrous oxide next. Then CO. Last is iso. So iso. So what is the importance of this blood gas partition coefficient?
If it is
What?
low, it has faster induction rate and faster recovery.
Induction, faster recovery. So you can remember wash in and wash out will be faster if the blood gas partition is lower. What is the oil partition gas partition coefficient important for?
It is a fat content.
It is the absorption by the fat. Okay, so prolonged lingering effect will be there. And what is the MAC important for?
Potency of
Comparing the potency. Very good. So the MAC value, if it is low, it is a highly potent agent. If it is high, it is a lesser potent agent. Okay. So the minimum quantity that can keep a patient unconscious indicates that it's a very potent agent. So here, if you see which is the most potent agent here among this all the gases, things that we have given.
Isoflurane.
Isoflurane has the lowest MAC. Okay, so that is the most potent agent among them. So don't go about by the number. MAC always lower the number, higher the potency, higher the number, lower the. Okay. So what are all the properties of an ideal anesthetic agent? Sometimes they may ask you to ease of use. It should not be flammable. It should not produce any toxicity to the organ, and it should have quicker onset or induction and emergence, easily titratable. It should be easily available. It should be less expensive. It should not have any pungent odor, and there should be no delirium or emergence hangover. Estimation of concentration should be easy. Estimation should be there, and provide muscle relaxation, and it should provide cardiovascular and bronchodilating properties. What is the checklist to be used before use of any anesthesia machine? This is another question that will be asked. I will go through that quickly. Check availability of working suction, ambu bag, and defibrillator. This is the first answer that you give. Then identify the source of gas supply, whether it is from central pipeline or from the cylinder mounted on the machine. Perform tuck test at the wall outlet to ensure secure connection. In case of central pipeline supply, make sure that there is a full or half full oxygen cylinder is attached to the machine. I don't know how many of you go back to your, see in your OT, go back to the backside of your workstation and see whether the oxygen cylinder is attached there, and whether it is the key is there, whether it is half full or not. I'm 100% sure none of you would have checked that, because in corporate hospitals you take it for granted that the oxygen delivery will be there all the time. But the common thing in the exam, they have to say this. They will always check the presence of oxygen cylinder in the machine by opening the cylinder and registering whether it is at least half full. And check flow of oxygen from auxiliary flow meter. That is another important, because this can be available even without the machine getting switched on. And turn the on in the mains power supply. Then check the flow of oxygen, nitrous oxide, and air. Check the hypoxic guard. How do you check for hypoxic guard?
So we have to try to open nitrous
without opening the oxygen. It should not open and flow. Number one. Number two, you open oxygen, open nitrous oxide, then close oxygen, nitrous oxide should also fall to 0. These are the two methods of checking whether the hypoxic guard is working or not. One is, do not open oxygen, try to open nitrous oxide, no nitrous oxide should flow. Second method is open oxygen, open nitrous oxide also, both should flow. Now close oxygen, nitrous oxide should fall back to 0. These are the two methods of checking for hypoxic guard. So close oxygen, nitrous oxide flow should stop and resume only when oxygen is open again. And inspect the vaporizers for reagent level, filling port, distal dial position, and open and close the dial setting to see whether it is moving freely. Okay. And the next is, how is the integrity of breathing system checked? That is the breathing circuit that you are using, the corrugated tubings and other things. How do you check for the whether it is leak proof leak is there or not?
Inner tube ethics test.
Ethic test for brain circuit.
Breathe. Mhm.
Here it is
For breathing system, it is universal.
leak test that you can do, but to first of all integrity, what you do is occlude the breathing tube by placing the thumb over the ET tube connecting port. That is a delivery port at the maximum at the Y junction of the, if you are going to use the circuit system, you use close the Y piece outlet. Then pressurize the circuit to 30 centimeters. You have the airway pressure gauge I showed you in the one of the earlier slides. So allow that oxygen to flow at 3 liters per minute and register. Now because you are occluding the outlet, the reservoir bag will start filling up and the oxygen pressure, the airway pressure gauge will start increasing. Set it at 30 centimeters of water, okay, by filling the bag. Then close the oxygen flow completely and watch the pressure gauge for pressure loss. So if it start decreasing from 30, say 28, 24, 26, that means there's a leak. It is not holding. And then turn on the vaporizer with no oxygen flow, watch for drop in pressure. And if at any point, if the pressure loss is detected, increase oxygen flow slowly until the pressure holds. So the amount of oxygen that you are required to bring back the pressure to 30 centimeters is the quantity of leak. Okay, so that is how you test for the leak, and you can also calculate the quantum or volume of leak also by this method. This is called the pressure check machine, circuit machine. And confirm that the leak does not exceed 300 ml per minute, and the leak is more than 300 ml, it needs to be corrected. Then open pop-off valve and confirm release of pressure. Check scavenging system. Confirm connected to pop-off valve. Turn to extractor. Confirm that is scavenging system measurement. And check ventilator function if fitted. So these are all the steps that you have to follow for testing or checking the machine. So this is where we thought of checking the internal leaks. What is shown here is the universal leak test, also known as negative pressure leak test. How is it done? How to do this?
We have to squeeze the bag and connect it to the machine when the machine is off, sir. It should not
So
refill.
switch the machine to off position. Very good. Then keep the flow meter and vaporizers also in off position. All the flow meters should be closed and vaporizers should be off position. Attach a suction bulb with a rubber tube and adapter to the common gas outlet. Then squeeze the suction bulb 2 times to collapse it like this. And it should remain collapsed for how many seconds or minutes?
Until we switch
10
it.
seconds. The bulb should remain collapsed at least for 10 seconds. If it collapsed for longer time, well and good. But minimum it should remain collapsed for 10 seconds, which indicates that there is no internal leak. Otherwise, what will happen? some air will come and it will inflate this bulb. So if the integrity of the circuit inside is very nice, it will be remaining collapsed for minimum 10 seconds. Now coming to the breathing systems which are attached to deliver the gases, we are going to that part. So how are they classified, breathing systems?
Open.
Functionally, it can be function wise or equipment wise. They are classified based on their function and equipment. So few examples of a function made by Drip, Vandam and Efkinov. They described it as insufflation system, open method, semi-open, semi-closed and closed. These 5 classifications were done by this. Moyer classified it as open, semi-open, semi-closed and closed. And Collins the same like that. And Adriani classified as the open vaporization, insufflation, semi-closed and closed. And Conway's open, semi-open, closed, semi-closed rebreathing and semi-closed absorption, semi-closed non-rebreathing. So these are all some of the classification made on the functional status of that. Equipment wise, they were taking into consideration the presence or absence of reservoir bag, rebreathing present or not, absorber present or not, and directional valves are present or not. So the classification is made on the construction of the breathing circuit using the various components, or it is made on the functional status, whether the patient is open to atmosphere or to the machine. When you say open, patient is breathing from the atmosphere and breathing out into the atmosphere. When you say semi-open, he is breathing from atmosphere, breathing from the machine and breathing out into the atmosphere. And semi-closed is also similar to that. When you say closed circuit, patient is breathing from the machine and breathing out into the machine. So that is the functional classification. Whereas construction wise, you can have a reservoir, you can have, where you don't have a reservoir bag, which circuit you don't have a reservoir bag, or which breathing system? ASTPs, okay? Whereas all other, mostly you have a reservoir bag. And how does the classification based on equipment differ from function? That is, it considers the equipment used for total gas flow. And if you say 2 liter fresh gas flow in a circle system, that is how you describe the based on the function. And based on the equipment, you can say this by Hamilton, which is so fresh gas flow required for various breathing systems is another common question they will ask you. So if it is Mapleson A, you require 70 to 80 ml per kg. And if you want to do control ventilation with that, you require a very large amount of ventilation. And that is why Mapleson A is not considered ideal for control ventilation, but it is ideal for spontaneous ventilation. And these are all classification of semi-closed circuit, semi-closed breathing systems. All the Mapleson's classifications are only about the semi-closed, not with the other functional status. So can you identify what is this particular breathing system is?
Modification of coaxium.
Modification
Lax circuit.
Lax. This is the this one is suited for spontaneous, and which one is suited for controlled ventilation? This. So parallel lax circuit suited for spontaneous ventilation. You can see there are 2 parallel circuit breathing tubes, corrugated tubes, and there is a expiratory valve at the above the reservoir bag. And this is parallel Bain circuit suited for controlled ventilation. Okay, so you have the gas delivery close to the patient. This is the inlet, that's the outlet. So this is supposed to be good for controlled ventilation. This is good for spontaneous ventilation. And some of the knowledge of various systems that is important for anesthesia you have to know is McGill's classification of various breathing circuits. And these are all semi-closed types. classified by Professor Mapleson. Knowledge about their function is important for choosing the right system for spontaneous or controlled ventilation. Okay. Nowadays, mostly spontaneous ventilation technique is almost become obsolete. For anything and everything, we now taught only to do controlled ventilation. Even for tonsillectomy, short procedures also are all done under controlled ventilation. But in the olden days, when we were postgraduates, we used to practice spontaneous ventilation for a large number of cases. And so this is the difference between the location of the fresh gas inlet, which is very, very important to identify what are the advantages, and valve location. If there is a pressure releasing valve or pop-off valve, that should be where it should be located, and whether they have a reservoir bag or not. The only circuit which does not have a reservoir bag is Mapleson E or ISTPs. Okay, that is the only circuit with no reservoir bag. All others have a reservoir bag, and corrugated rubber tubing is present mostly for all except Mapleson C. Okay, and Mapleson C is almost it's equal to ambu bag. That doesn't also have a corrugated tubing. So the only use of Mapleson C is now we have still in ambu bag. Mapleson B is not used anymore. Mapleson A is sometimes used in some hospitals, and ISTPs is the one for pediatric, and Jackson 3 modification is Mapleson F. So these are all the common points that you have to remember with regard to arrangement. And this is how the coaxial latch circuit works. And this is called, if the tube is going inside, the outer tube is the inspiratory limb that is delivering the fresh gas flow, and the inner tube is the X-ray taking out the expired gases. So this is called the latch circuit. If it is reversed, if the inner tube is the inspiratory fresh gas flow tube, and the outer tube is the expiratory limb, that is Bain circuit. So that is the difference between the tube. And if the two tubes are separately placed, then it is called the parallel latch circuit. One for allowing fresh gas flow, and another to deliver the exhaled air. Then it becomes a parallel latch circuit. This is a coaxial latch circuit. And another important confusing thing is what is afferent reservoir breathing system and what is efferent reservoir breathing system. This is another classification based on the location of the breathing reservoir bag.
That is A, B, C Mapleson, sir.
If it is in the inspiratory limb, then it is afferent reservoir. If it is in the expiratory limb, then efferent reservoir.
Efferent. So the afferent limb is the part of the breathing system that delivers fresh gas flow from the machine to the patient. So if the reservoir bag is placed in this limb, they are known as afferent reservoir bag. So the examples are Mapleson A, B, and C. These are the three circuits which are called afferent limb or afferent reservoir. When the thing is in the efferent limb, that is the exhaled limb, then it is called the efferent reservoir, and the examples are D, E, and F. So this is easy to remember. And the volume of fresh gas flow required will be varying based on the this particular classification. That is the importance of this. Now identify the breathing system shown here. So this is an enclosed afferent reservoir system. This, as you can see, the reservoir bag in a enclosure, and one is directly connected to that. The other one is the this bottle is connected as an expiratory limb. So of course it is not very necessary, right? And who introduced the breathing system? They are Miller and D.M. Miller and J.C. Miller. And what is the importance of fresh gas flow? What is it? Low fresh gas flow will result in carbon dioxide retention. If you keep a high fresh gas flow, what will happen?
Narcosis.
It will be wasted and it will cause pollution. Okay. and optimal fresh gas flow will prevent both the problems. So low fresh gas flow, carbon dioxide not properly eliminated. High gas flow, wastage of gases. So you should have an optimal gas flow. What is apparatus dead space? This is one of the important points from practical point of view also. And how is it measured?
It is the amount of gas which does not take part in ventilation, which is occupied in the apparatus by adding extra.
So how can you measure? What points you have to measure the volume? It is measured at 2 points. One is at the point of entry of fresh gas flow or at the position of the expiratory valve. Okay. So apparatus dead space defined as the space resulting from devices placed between the endotracheal tube and the Y-piece of the breathing circuit, and is the primary source of dead space controlled by the clinician. So we can control it. And it is measured at the level of expiratory valve in afferent reservoir system. That is when the bag is in the inspiratory limb, or at the level of fresh gas inlet in efferent reservoir system. These are the 2 points. So this picture will tell you clearly, this is the afferent reservoir system where the expiratory limb is very close to the attachment of endotracheal tube. So this portion only is the dead space. All these things will not included. Whereas in the efferent reservoir, always you know that the fresh gas flow is very close to the patient's breathing system or respiratory tract. So this is the dead space. And in the circle system, it is at the junction of the Y-piece. Okay? So this is the common 3 things that you have to remember, how the dead space. And factors that alter dead space are, if you increase in the mechanical ventilation using large NAV mask, it's like a big HME, humidifier moisture exchanger, you can reduce the use of, reduce the dead space by using ET tube or in a patient with tracheostomy. Tracheostomy is supposed to completely eliminate the anatomical dead space, not the apparatus dead space, but it will eliminate because the entire upper airway is bypassed to go directly to the trachea. And apparatus dead space calculated in vein circuit. And what will happen if the inner tube is broken? This is one of the common quiz questions they ask you.
The whole tube will become a dead space.
It is at the point of delivery of the fresh gas flow, which is close to the patient. So apparatus dead space is very minimal in vein circuit. But if the inner tube is broken, what will happen?
The entire tube will become a
entire
dead space.
expiratory tube will become. So this is the afferent limb, and this is the patient. So this is the efferent limb, and because it is very close to the patient, apparatus dead space is very minimal. But if the inner tube is broken, then what happens? The entire corrugated tube becomes the dead space, and that will cause accumulation of CO2. Now, what is shown here? It's one of the older things, just for historical purpose.
Waters to and fro.
This is called waters to and fro system. Example of bidirectional flow system, the canister to absorb carbon dioxide. So he used soda lime absorption for carbon dioxide elimination as early as like that. And there is no corrugated tube here also. You can see the bag is directly attached to the canister and the fresh gas flow is going here. So what will be the dead space here? At this point to this point. Okay? From here to here only the dead space, because the fresh gas flow is coming in here. Okay? And under which class of Mapleson? It comes under Mapleson C, because there is no corrugated tubing, just like your ambu bag. And this is the ambu bag component. We are now going to the equipment part slowly. So ambu bag is a common equipment that may be given. Can you identify all the parts in this?
Face mask.
Face mask, okay.
Inspiratory valve.
Valve, okay.
Pressure relieving valve.
Valve.
Self-inflating bag.
Self-inflating bag, very good. What is this green tube?
Oxygen port,
Oxygen port. This is
the reservoir
reservoir
bags.
bag, and this is the release bag. Okay, right.
Yes, sir.
So AMBU stands for Artificial Manual Breathing Unit or Air Mask Bag Unit. So these are the any way you can describe. So this is the face mask, this respiratory valve, there's a PEEP valve. This red thing is the PEEP valve. You can give PEEP also. And there is a pop-up valve, there is a self-inflating bag. There is a air inlet here for the one-way valve to our oxygen reservoir socket. And you have air inlet pressure release valve. You have the reservoir bag, oxygen inlet tubing. All these things are there. And now I am showing pictures of two things. What are they? What are shown in this and what is the difference? What is their use?
Soda lime with different color indicator.
Okay. Which one is in the older machine? Which one is in the newer machine?
Below
Top
is
one or
This
bottom?
one is New Year's.
This is on the modern machine. Okay. Soda lime, what is a soda lime? It's a granular substance used in anesthesia machine to remove carbon dioxide from the exhaled breath. This top one is in the anesthesia workstation and the bottom one is in the older anesthesia machines. And are you seeing this in every day in your from when you look at the front of the machine?
Yes, sir.
It's not so easily visible. You know, it will be on the side and the behind the control panel for switching over from oxygen, bag to ventilator and APL valve and all those things. Whereas this will be very easily seen on the very outside. Okay, and the top one has a single chamber. You can see that it's a single chamber canister, whereas here is the bottom is a two chamber canister. And what is the reaction that takes place to remove carbon dioxide when you use soda lime?
exothermic reaction.
Exothermic reaction. What are all the steps you have to say?
Steps.
That's a very,
Um,
very common question. What is the composition of soda lime?
Sodium
hydroxide,
hydroxide, calcium
and
hydroxide, potassium hydroxide.
Potassium hydroxide was there earlier, but now they have removed it. It is only calcium and sodium hydroxide. Which is the major component?
Calcium.
Calcium hydroxide. Even though it is called soda lime, sodium is only very small quantity. It's an activator, whereas calcium is the main absorbent. So actually it should be called calcio lime, not soda lime. So the reactions are in three steps. Reaction at the aqueous layer, where carbon dioxide will, there is always some water vapor inside that. So it will mix with the water to form unstable carbonic acid. That will break down to form bicarbonate and hydrogen ion, as you know, and that will activate or mix with the sodium hydroxide first, and that will become sodium bicarbonate. So the second step is bicarbonate formation. Then this bicarbonate will react with calcium hydroxide to make it calcium carbonate, and it will regenerate back to sodium hydroxide and water. So this is a decomposition or regeneration step. So three steps are: first, conversion of carbon dioxide into carbonic acid, breakdown of carbonic acid into hydrogen and bicarbonate, and which will combine with the sodium hydroxide to form sodium bicarbonate. Sodium bicarbonate will react with calcium hydroxide to form calcium carbonate and regenerate sodium hydroxide and water. So that is the three-step reaction that you have to remember. And what is Monday morning syndrome?
When we forgot to switch off the vaporizer.
After 5 days continuous using, will get one.
Right. Okay. The Monday morning syndrome refers to a potential risk of carbon monoxide poisoning that can occur when an anesthesia machine is used for the first patient on a Monday morning after being idle over the weekend due to a chemical reaction between the volatile anesthetic agent and the carbon dioxide absorbent. Okay. When anesthesia machine is left unused for a long time, the soda lime can become partially desiccated. That means it will become dry, leading to higher chance of production because we need water to convert this carbon dioxide into carbonic acid. So when you have a dry soda lime, it leads to higher chance of producing carbon monoxide when a volatile anesthetic is used. Okay? So regularly changing the carbon dioxide absorbent, flushing the breathing circuit with fresh gas flow, fresh gas before the first patient on Monday, and monitoring for signs of carbon monoxide are the methods of preventing this poisoning with carbon dioxide, which is called Monday morning syndrome. What is displayed here?
Vein circuit.
Adult vein circuit. Okay, adult vein circuit. What is displayed here?
Pediatric.
Pediatric. The indicator is the small face mask. Okay, so this is a, and you can see the inner tube is outside. It is not like the adult vein circuit where the green tube you can see is inside. Whereas in the pediatric, it is outside. Okay, so this is the pediatric vein circuit with a mask. What are the dimensions of vein circuit, which is used normally, and one which is used in MRI suit?
180 centimeter
80
in
centimeter.
1.8 and 5.4.
5.4.
Okay, 5.4 meters for MRI. Normal is 1.6 or 1.8. Both have 22 millimeter outer corrugated tube and 6 millimeter inner green PVC tube. What are the indications for use of pediatric vein circuit?
For control ventilation.
They are used mainly in
More than
endoscopy
25.
suit and MRI suits. Okay, indications where you can use them are for these two. What are the advantages and hazards of this circuit? What is this circuit?
JR circuit.
Jackson trees.
Jackson
Okay.
is
Advantages are it's lightweight and portable, no valves, so no resistance, and can be used for both spontaneous and controlled ventilation. Minimal apparatus bed space. But the disadvantage requires a high flow rate to prevent rebreathing, air dilution, and hence it will cause wastage of gases, pollution, uneconomical, and drying of the respiratory tract. This is a metal ISTPs used in the olden days. Okay, just for comparison I'm giving, and this is another modification of the reservoir bank. Jackson Tree said there should be an open tail for the reservoir bank, but somebody found it difficult to use control ventilation with this because you have to pinch and release this every time. You have to use two hands. Instead of that, to use it with one hand, somebody made a hole in that, and this is called
Kun bag.
spoon bag. Okay, and very good. So these are all the different types of tea pieces, metal pieces. It is called the classical, modified, Washington, and Norman. And what is shown here, especially this,
This one.
Monitoring.
maybe depth of anesthesia
Monitoring.
monitoring. We do not know whether it is this or so. What is entropy? This monitoring all of you know, regularly used. But entropy monitoring is also another method of monitoring the depth of anesthesia. What is the definition of entropy? It is the measure of irregularity in any signal. Okay? When you are able to measure the irregularity in any signal, that is called entropy. What are the types of entropy? SE and RE, state entropy and response entropy. Okay, there are two types of parameters reacting to response entropy and the more steady or robust state entropy. So what are the characters of both response and state entropy? State consists of entropy of EEG signals calculated up to 32 Hertz. Whereas response entropy includes additional high frequencies up to 47 Hertz. So consequently, fast frontal EMG signals enable a fast response to response entropy. That is the character. What display will be seen when you switch on entropy monitoring? First, there will be a sensor check will be shown. which will show that sensor placement are correct. Then next will be the values of response entropy and burst suppression ratio will come. So these three values will be displayed. I'm just giving this because supposing they keep this monitor, you should not feel lost. So these are all the parameters that we can get, and the values at various depths are displayed like this. Here also it is 0 to 100 like your BIS monitor with no units attached, but the values are slightly different for the RE and SE. So 190 it is called awake, and it is 60 for both is for low probability of recall, and 40 just like this it's called clinical adequate level of surgical depth of anesthesia, and below 40 it's all deep anesthesia. Now what is the procedure being performed here? Seen
Directly.
microlaryngeal surgery with a high frequency jet ventilation, and this equipment
Manual jet.
this is the Sanders jet ventilation. Okay, and what is the principle behind the jet ventilation?
Bernoulli's.
Venturi principle. So Venturi effect, based on Bernoulli. Bernoulli said there is a drop in pressure, but Venturi said it can entrain by addition of the air or fluid. So other applications of Venturi.
Venturi mask.
Venturi
Venturi mask, very good.
Nebulizer.
And modern vaporizers also use that. Okay, and what is shown here?
Warmers.
Warmer, also called bear hugger, a warming blanket. Okay, what is it used and how does it work? Why is it used?
To maintain the temperature.
Normothermia. Okay, very good. Keep patients warm before, during, and after surgery. Bear hugger warming system draws filtered air through the operating room, passes it through an internal filter, and warms the air to the selected temperature. And warmed air flows to a single-use bear hugger warming blanket through an enclosed hose, then gently dispersed across the surface of the skin. Okay. What are the mechanisms by which heat will be lost by patients in OT?
Radiation, evaporation, conduction, convection.
Convection, okay. And also respiration. What are the methods to reduce the heat loss?
By decreasing the ambient temperature, by increasing the ambient temperatures, then by covering the patient, actively warming using fluid warmers and bear hugger warmers.
Very good. Okay. So then all IV fluids be warmed, inspired gases to be humidified and warmed. What is defined hypothermia and why should it be avoided?
The temperature rate is less than 34 degrees Celsius, it is hypothermia.
Why should it be avoided?
It causes decrease in the metabolism of
More temperature less than 36 is hypothermia. It causes hypotension, bradycardia in the cardiovascular system, and ventricular fibrillation also can occur. RS, it shifts the ODC curve to the left, can cause pulmonary edema. CNS, it will cause depression and prolongation of drug effect, decrease in renal function, hyperglycemia, and decreased coagulation. Okay. What is the equipment shown here?
ultrasound.
It's a handheld portable ultrasound machine. What is the application in anesthesia? We are using it for so many things here. Okay?
Venous
It can be used for
cannulation,
vascular access, regional access, transesophageal, echo, ultrasound, everything can be. What is its use in neuromonitoring?
What's the ICP, sir?
ICP
As
specific.
transcranial
Transcranial Doppler is a different thing. So it can be used for assessing elevated ICP and cerebral perfusion. Current potential applications are optic nerve sheath diameter measurement, which is an indirect measurement of the intracranial pressure. And you can use transcranial Doppler ultrasound if you have. And pupillary light reflex also can be used by using this. Very simple equipment that you are using every day. What are all, can you name the parts that have been marked here with the line?
Consists of
Starting
a
from the
flange, a handle,
this is the tongue
light
blade
source.
entire thing. This is the hook on for the base.
Peel.
So what is the tip called? The name for the tip. This is a Macintosh curved blade laryngoscope for use in adults. Okay. So the parts are the big tip, and the whole thing is called this flange. And this is the vertical step, that height that is rising from that. This is the tongue blade or spatula. This is the hook on base. This is the handle. Okay. These are all various varieties of or sizes of curved blade as well as straight blade. And what is the difference in using straight and curved blade?
Straight blade is used in the pediatric, which used to lift the epiglottis, which
You
includes
have to
the
include the epiglottis also in straight blade, whereas you place the blade tip in the vallicula before the epiglottis and elevate them. Okay, so you don't include the tip elevate. Sorry, epiglottis in the curved blade. What is this? What are the advantages? What laryngoscope is this? They have a handle, the tip can bend. Not seen
McCoy.
at all?
McCoy blade.
Yeah, this is called
McCoy.
McCoy laryngoscope. Okay, by lifting and folding the epiglottis helps in seeing the glottis without the need for external pressure or burst. That is the advantage of this particular instrument. So, how are video laryngoscopes classified? Nowadays, all of you will be very familiar with the video laryngoscope usage. How is it classified? Okay, there are a lot of classifications. So it can be integrated channel laryngoscope, video stylates, or rigid blade. These are the examples. Another method of simple is non-channeled and channeled video laryngoscopes. Okay, and which one? I think VMAC. Are you using?
Yes, sir. CMA.
This is a common thing. I think most of you should be well versed with. So VMAC comes under which category? Non-channeled.
Non-channel.
Rigid blade, non-channel. Okay, so that is the classification that we have. Of course, this is the flexible fiber optic bronchoscope. So the difference here, what is the difference between this and this? But this one, these two are the close-up view of this, and these two are different. What is the difference between these? What is this called? What is this called? What is this portion?
Eyepiece is
Eyepiece.
there.
Eyepiece. So this is
not
called flexible fiber optic bronchoscope. Okay, which the eyepiece is attached and you have to look through the eyepiece bending your head. This is called flexible fiber optic bronchoscope. On the contrary, you attach it elsewhere and you don't have an eyepiece, that is called videoscope. Flexible fiber optic videoscope, because you will be seeing through the monitor. Okay, so eyepiece present in bronchoscope and absent in videoscope. So if they show you these two different categories of fiber optic equipment, you have to know which one is bronchoscope, which one is videoscope. And the parts are eyepiece, diopter ring focusing, and control lever. All these things are given here. What is the working principle of fiber optic bronchoscope? It is a
Total.
bundle of glass fibers. Okay, and they transmit light and then capture image and retransmit it to be seen in the eyepiece or the video monitoring. Okay, a non-coherent bundle of glass fibers illuminate the airway, and a coherent bundle of glass fibers transmit images back to the video screen. And we are, what is the purpose of this working channel, which is seen here? You can see that this is a working channel that is used for suction or installation of local anesthetic, or you can do bronchoalveolar lavage, or you can use biopsy by putting a forceps inside. So these are the things. I forgot to animate it. And, this is the nitrolaryngeal surgery scope. This is the rigid ventilating bronchoscope. This is the what is being attached here.
Circuit is attached to the
Breathing
ventilating.
circuit. There is breathing circuit attached to the side port. Okay. And this is again, you have seen jet ventilation. This is called manu-jet. And this is the, here you have a button-like thing. Here you have a handle which is projected. So it is the difference between the two is manu-jet. What are shown here? These are all continuation of equipments.
Gum elastic bougie and airway exchange
A,
catheters.
B, C, D. It's all classified. So picture showing various intubation aids. A is various sizes of stillets. Okay. B is different types of bougie. You can see the small bend here. We call the coud tip, C-O-U-D-E, coud tip. And C is
Airway.
hollow bougie. Okay, hollow bougies are a tube exchanger, and D is airway exchanger with oxygen port. You can see the tip here where you can give oxygen. So you place that in cases of difficult airway and then remove the endotracheal tube, and you can ventilate the patient or supplement oxygen through this. And if there is any difficulty, you can railroad the tube again. So this is the airway exchanger. And what is this? You have three colors. What are these colors commonly seen? Where do you see these colors? Red, amber, and green.
Electric.
LME.
Traffic light.
Traffic
Okay,
signal.
so this is called traffic light bougie, and they can determine how much you have to insert. Okay, insertion till green is safe, yellow slightly deeper, and red will cause carinal damage. So when you introduce it for difficult intubation, you know how much to insert instead of blindly pushing it too far. Okay, what is shown here?
Color coded oropharyngeal airway.
Oral pharyngeal airway. Very good. Very good. This
Different sizes of nasopharyngeal.
where are sizes of nasal airway. Very good. How to measure the size of the oral and nasal airway?
So for oral airway, it is from the angle of the mouth to the angle of the mandible.
Very good.
For nasopharyngeal airway, it is from the ala of the nose to the tragus.
Excellent. Very good. So oral angle of the mouth to angle of mandible, and nasal tragus to nostril. Okay. This is called ovosapien airway. Where is it used?
In the fiber optic.
Fiber optic intubation. Okay. This is called Bergman airway for fiber optic. And this is how the scope is passed through that. These are all plastic suction catheters, color coded of various sizes. And what is this?
Suction catheter.
Suction, same catheter only, but
Closed catheter.
that's a valve to control. You can apply your thumb and prevent the suction being done
Closed
when you
catheter,
introduce it.
sir.
Huh?
Portable suction.
Portable suction catheter with a control. Okay, by closing this tip, this hole with your thumb, you can avoid suction when you are inserting the catheter. Whereas in these things, you have to bend it and you have to prevent the suction being applied when it is inserted. Whereas here you can just close it, and once all the length, adequate length is inserted, especially into tracheal suction by through endotracheal tube, you have to avoid suctioning when you are introducing the catheter. so that can be achieved. And these are all the different thing color coded with a stopper also, which can be introduced into that. And this is, what is this?
Yonker suction.
Yanker, very good. Yanker plastic suction tip with a tube. And what is this? Used during
Closed suction.
Closed to section.
closed suction catheter. Very good. Right. What is this?
CVP.
Pulmonary
pH pulmonary catheters.
PA catheter, also known as Swan gas catheter or yellow snake. Okay, name the parts. How many ports are there?
4 ports.
What are they for?
One is for thermistor, another
So
one is
you
for
can
catheters.
balloon, thermistor, CVP port, and PA port. Okay, what are the indications for use of this? Okay, continuous cardiac output monitoring, central temperature monitoring, measurement of PA pressure, and measurement of mixed venous oxygen saturation, estimation of diastolic filling pressure. Mention few complications of this use.
Pulmonary artery rupture.
Arrhythmia.
Arrhythmias, very good.
Bleeding.
Pulmonary artery rupture, infection, thromboembolic complication, catheter knotting, valvular damage, air embolism. Okay, what is this?
Color coded different size of face mask.
Inflatable, transparent, disposable face mask. Okay, of various sizes. What is this?
Antiseptic mask of size 5.
Anesthetic, antistatic, anatomical face mask. Okay, made of rubber. So this is black rubber anatomical face mask. What are these?
Pediatric differences.
Pediatric. Any name for that?
Dental Baker's.
Tender Baker Sosek mask. Very good. Okay. What is this? Mask used for endoscopy. Transparent face mask for, so you can hold the mask and pass the endoscope through this. Okay. And what is this?
NIV mask.
NIV or CPAP mask. Very good. What is this? This is a harness. It's called the harness. Okay. You can, this goes to the occipital area, and these straps you can hook on to these metal portions here. Okay. So sometimes if they have this, they may ask you what is this for. So instead of holding the mask with your hand all the time, this broader portion you have to keep it under the occiput of the patient and bring the straps and attach it to the the projections that are there here, hooks here, and that will stay in place, and you can look at the WhatsApp without holding the mask. Okay. This is adjustable venturi mask. So what is the principle of venturi? It entrains air and dilutes that. So you must be able to know what are all the various color codes and what is the maximum percentage that you can develop. Okay. So you have to identify all this. Can you identify this one?
Ambu mask.
Go back with the reservoir.
CPAP
Mask. Nasal
mask.
props. Nasal cannula.
nasal prongs,
Okay.
hyperbaric
It's a non-breathing
non-breathing
mask.
Non-breathing portion.
This is hyperbaric chamber. This is Hudson mask. Okay. Ambu bag, CPAP mask, nasal prongs, face mask with reservoir, hyperbaric chamber, and Hudson mask. What is this instrument?
Hassafed
This is a high flow nasal
nasal
oxygen.
oxygen.
This
Oxygen concentrator.
oxygen concentrator. Very good. This is
one way flow.
non-rebreathing mask. One way valve means there's no rebreathing. Okay. Identify the items here.
Color coded
Pink spinal needle.
Different spinal needles. Very good. So these are all the different tips. Pinky, acres, throat, and green. What is this?
combined spinal epidural kits.
Epidural set. Very good. What is this?
Epidural
Epidural needles with
different size.
Detachable wings.
epidural needle சொல்லணுமா இல்ல trophy
Two
needle
guys.
trophy needle. Is it introduced by Tuki or somebody else, this needle?
Somebody else said.
Who is that person? Actually, the tip, what is the difference between your regular spinal needle and this Tuki needle?
Curved tip. Huber
That is called Huber point. Okay, the Huber is a person who introduced this curve, and Tuki was only responsible for popularizing it. Huber is actually a dentist, German dentist. So he used the little curve in the needle to prevent pain during injection. And Tuki is a American anesthesiologist. So he thought by using this we can avoid the puncture of the dura. So he introduced so actually it should be called Huber point Tuki needle. Okay, and what is this for?
base wings.
Base wing or
Hold
flange.
the
And what is the advantage of attaching this flange? What technique you can practice to identify epidural stage?
loss of
Of resistance.
Loss of resistance இது வேண்டாம். Hanging drop. This is useful for doing the hanging drop technique. Okay. And what
Yes.
is this?
Patient
Nothing.
control analgesia.
The whole set is called elastomeric pump. Okay, infusion pump, which can be used for post-op pain relief. And of course, patient also can control this by pressing the button. But this is called the elastomeric infusion pump used for post-op analgesia. In the gadget, it's called Baska mask. To which generation does it belong?
Second generation cuffless LMA.
Third generation SAG, because it has got twin tubes. Second generation has got only one drainage tube, whereas third generation 2 tubes are there. The parts are, of course, this is a cuff orifice, this is a pharyngeal drainage end, the suction axis, there are device stuff, bite block, airway channel. Who designed this? Dr. Kanak Baska and his wife, Dr. Meena Baska. Okay, these are the people. How are LMA classified?
So based on generation and based on the sealing pressure and the gastric bone.
Very good. Based on sealing mechanism, it can be called perilaryngeal sealers, pharyngeal sealers, or both. Okay. And based on the evolution, it can be called first generation, second generation, and third generation. And third generation only, Baska mask comes. Who is this person?
Archie Brain.
Archie Brain. Very good. His full name is, anybody can say his full name?
No, sir.
Okay, Archie Ian Jeremy Brain, British anesthetist, inventor of laryngeal mask airway. Which is the fourth generation LM?
It is
Type of LMA.
Video laryngeal mask airway. Okay, it's the fourth generation, combines double tube LMA with the video laryngoscope. Okay, so this is the picture of that. You can see this is the detached, this is the mask without the attachment. Then you introduce the fibroscope through one port. This is a suction, this is a ventilating port. Using this monitor, you can intubate or you can identify it at the correct location also. This has become the fourth generation LM. Shown are some pictures, similar looking tubes.
laser tubes.
Laser tubes, of course. All of them are used during laser surgery. This is called rush laser tube. This is Mallinckrodt laser with a double cuff and Bivona foam cuff. So instead of air, it is already filled with foam and then void. So what should be done if airway fire happens during laser surgery?
Cut off all oxygen and gases.
Silent.
What are the 4 E's you should practice? 4 E's to be done are eliminate the source further by switching off oxygen, evacuate by removing the ET tube, extinguish by flooding with saline, and evaluate the airway damage and restore ventilation. Okay, these are the 4 E's you have to know. This is a very common, very basic thing. Name the parts of your tube that you are using every day. Tracheal tube. Sometimes the basic things may floor you, so better to know everything about the basic instruments. What is A?
Pilot balloon inlet.
Pilot balloon, pilot inflation valve, C and D.
Female connector.
ET tube connector.
Universal connector, called it connector. F is body, G. What is this? G, H, and I.
H is
J.
high volume, low pressure cuff, and I is tip. J is Murphy size.
Murphy side. So right. So you can see the pilot balloon. Muggles have radius. So this is the question that may be asked. What is the curvature is? It is the radius of 140 millimeter. And this black line is called the vocal cord guide. And you can stop at that so that you don't push the tube too much inside. These are all thoughts of what?
Combi tubes, sir.
Tracheostomy tube.
Tracheostomy tube. Very short one. Tracheostomy tube. So again, this is a inflating valve. This is a pilot balloon. This is the cuff.
Cuff tracheostomy
What
tube.
are these two?
Inner tube and introducer.
It is called obturator, not introducer. So these are all the names. So this is the valve, that's the pilot balloon cuff, and this is the faceplate, or with the slots for tying the knots that keep it in place. This is a disposable inner cannula, and this is the obturator for introducing. What are the indications for tracheostomy? Just mention a few.
Emergency and elective indications.
Airway obstruction, prolonged ventilation, and remove secretions. Okay. And what is this?
4th generation LMA. LMA with video.
Video laryngoscopy. Okay. What is this? All the bond fields intubating stillet. Can you identify these two?
Muggles.
This is Muggles. Very good. What is this? So one is called Suzy and Bodecker forceps for using with video laryngoscope. This top one. This is because Muggles is used for direct laryngoscopic intubation. So when you use video laryngoscope, you have to use this for guiding the tube, and that is called Suzy Bodecker forceps. Whereas this is your standard Muggles forceps. Okay. What is shown here?
Double lumen tube.
Double lumen tube. Very good. The weight is thumb control. Okay. What are the indications for double lumen tube?
Absolute indication and relative.
Absolute and relative. Okay. All of you know about that. So lung separation. Okay. Can you identify this? This is for pediatric use. Okay. And this is called Mara-Rose bilumen tube for children where you want to do the lung isolation. And this is DL tube for patients with tracheostomy. Okay. And this is bronchial blocker. It's called easy blocker. It's written EZ. This is the normal length. Advantages are easy placement, complete isolation. And it is a 7-inch polyurethane catheter. Of course, will not go into all the details. Airway adjuncts are shown here. What are the things? These are all. Can you identify the 3 tubes here?
RAE tube.
This is the RAE. All of them are RAE.
No, second one is
First
RAE.
two.
Second one is, middle one is RAE. What is this and what is this?
Last one is Oxford tube.
This is Oxford, very good. Older tube which was used for cleft lip and or oral surgeries. This is Oxford tube, red rubber. This is called anatomical tube. Okay, for preformed anatomical tube, oral ray tube, and Oxford tube. And this is the nasal plain red
Red
rubber
rubber.
tube. And this is soft oral red rubber tube. This is your
Reinforced.
Montan lens tube used for tracheostomy patients. And this is various connectors, PT tube connectors called Cardiff, McGill, Oxford, Penlon, etc. And this is sterile anchor suction. This is closed suction catheter. And who is the Admon outing here?
IV set cam.
IV set
IV.
cannula. Okay, right. What is shown here?
Peripheral nerve
Peripheral
stimulator.
Terminator.
Peripheral nerve locator. Okay, used for nerve block. And what is this?
NMJ
The neuromuscular
The
monitor.
neuromuscular junction monitor. Okay, so there is a difference between these two. Why? What is the difference?
That amplitude, sir.
Maximum amplitude is only 5 milliamperes. That's current strength. Whereas here it can go up to 80 milliamperes. And this is a very rough type of neuromuscular junction monitor for monitoring the neuromuscular junction activity after a muscle relaxation, to assess the recovery and things. Okay. What is chronoxy and Riobase?
Riobase is the strength to produce
strength of the current.
Strength of the
Chronoxy
stimulus.
is
Very good.
stimulus.
And chronoxy is the
duration of
Chronoxy is the time
time.
required to
Excel.
produce twice
So
the
chrono
Riobase.
means number. Okay, so remember that chronoxy and Riobase are electrical parameters that describe how stimulus affects the neuron or muscle. Chronoxy is the minimum time required for a stimulus to produce a response, and Riobase is the minimum current stimulus strength to elicit a response. Okay. What is being shown here?
Pulse oximetry.
Finger probe pulse oximetry. What are the things that are displayed in this?
SpO2 pulse rate,
pulse rate,
Saturation,
index,
pulse rate, respiratory rate,
pulse
respiratory
rate,
rate,
pulse variation
breath
index,
index.
breath index, and also the waveform is there. Okay. So displays SpO2, oxygen saturation, pulse rate, plethysmography tracing, battery charging, everything. So what is the pulse variability index? Breath variability index?
The area under the curve
Helps
will
the strength of the peripheral circulation. Assess the strength of the peripheral circulation. What is Massimo, which is written here? The name of the American company. It's a non-invasive monitoring agent making the monitor, and it uses a technology called signal extraction technology to remove artifacts and motion-induced changes. Okay, and what is shown here?
ICD with
intercostal tube.
Three
With
types of
bottle.
ICD drainage. One is one bottle
One
system,
bottle.
second is two bottle system, and third is the third bottle system. So what is the indication for each of these? Use of, what is the indication for ICD mainly?
for large pleural effusion, massive pneumothorax, hydropneumothorax.
Remove blood or fluid from pleural space. Okay, a simple answer. What should it be? What should be the height of the water in the bottle?
4 centimeter.
Minimum 2 centimeters. Okay. What are the advantages of two bottle system?
Suction in separate bottle and drainage in separate bottle.
Suction comes with a 3 bottle. Okay. Separate the fluid collection and fix the underwater seal will be there. Because if you use one bottle, as the fluid comes, so the height of the water column will increase and it will cause more resistance to breathing. Whereas if you collect the fluid separately, and this water column will be the same. So patient will have fixed underwater seal. And if you add the third bottle, you can apply controlled suction to expand the lung faster. So there are advantages of 3 are adjustable pressure suction drains both fluid and air. No reflex back of the fluid will happen. How far below the patient's chest these bottles should be kept?
100 centimeters.
100 centimeters. Very good. What is the safe triangle for insertion of ICD?
It
And
is
what are the
formed
boundaries?
by borders of latissimus dorsi and pectoralis major. Basis by the
So
line
this is
drawn
the
from the
anterior
neck.
border of latissimus dorsi, lateral border of pectoralis major, and the fourth intercostal space along the nipple and the apex of the axilla. Okay, all these things are there. And that picture is there. Nowadays, nobody uses the bottle. It goes with the disposable bags like this. So you have to fill water first up to the mark that is given, the water level, and then attach the bag to that. So what is shown here?
Arterial and flex. No, arterial line.
Arterial pressure transducer. This is a BP
Transducer.
measurement transducer with a connection. What are the main components of intra-arterial blood pressure monitoring system?
Cannula,
Intra-arterial cannula, fluid-filled tubing, transducer, infusion and fluid flushing system, signal processor amplifier display. What is Fourier analysis? Right. The process of analyzing a complex waveform in terms of its constituent sine waveform is called Fourier analysis. Sine wave is simply a wave like this with a base line. So it is imagining a upward stroke and a downward stroke, upward stroke and the sun. That is a simple sine wave. So when the becomes complex, you can break down it into the basic sine wave, and that is called the Fourier analysis. What is natural frequency of a commercially available intra-arterial TP measurement set, and what factors increase or decrease it? Natural frequency is about 200 hertz. Okay, and this can be increased by reducing the length of the cannula, reducing the compliance of the cannula or diaphragm, reducing the density of the fluid used in tubing, and increasing the diameter of the cannula or tubing. And the natural frequency can be reduced by addition of three-way taps, bubbles, clots, and addition of lengthy tubing. What is damping? What factors increase it?
air bubble.
What is damping? First define damping and then say what are the things that are affecting it. Damp means my mood is dampened. You are depressed or you are suppressed, isn't it? So damping is a reduction of energy in an oscillating system which reduces the amplitude of the oscillations. Okay. And three-way taps, bubbles, clots, vasospasm, narrow or long compliant tubing, kinks, and cannula are the factors which will increase the damping. And why should a pressure transducer be positioned at the same level of as the patient's heart? Right. The answer is it is corrected by avoiding the hydrostatic pressure. For example, if you keep the transducer above the patient's heart, what will happen?
To show
This fluid
low
column will offer
Low
show
beat,
low
Ah.
beat.
lower values.
Low
so the
systolic.
pressure values will be different. Okay, so it will all get altered. What is shown here?
Cardiopulmonary bypass.
Cardiopulmonary bypass machine. What are the components of that?
Venous cannula, reservoir, oxygenator, pump.
So all these things consist of venous cannula, reservoir to hold blood, pump to circulate, oxygenator to add oxygen, heat exchanger to control temperature, arterial cannula to deliver the oxygenated blood back to the patient. What are the types of pumps used?
Roller pump and centrifugal pumps.
Solar and centrifugal. What are the types of oxygenators used?
Bubble oxygenator and membrane oxygenator.
Membrane oxygenator. What is the difference between pulsatile and non-pulsatile flow?
Pulsatile flow will replicate the normal arterial flows, which is
Oh.
provided by the roller pumps.
So pulsations, non-pulsatile. So it ensures that the microcirculation is preserved by pulsatile flow. Okay, non-pulsatile flow can lead to unbalanced distribution of blood flow. We come to the last one. What is shown here?
Defibrillators.
Defibrillator. Okay, it's an external defibrillator.
Yes.
What is a defibrillator?
The electric current produced in the cells.
Huh? What is a defibrillator? It's a device that applies an electric charge or current to the heart to restore to normal heart rhythm. What are the types of current applied? Which one is preferred? Why?
So alternating current and direct currents.
Monophasic and biphasic. Okay. So preferred is biphasic because it's more effective and less energy, less trauma to just work. What are the types of paddles used and where are they used?
Right and here. And
Types of paddles, first of all, is
Disposable paddle.
can be
Disposable and
paddles for internal fibrillation, adult and pediatric, handheld. This is a handheld paddle for external defibrillation, and adult adhesive pads which are stuck to the patient's body in automated external defibrillation. So there are 3 different types of paddles that are used. What are the indications and contraindications for defibrillation?
Indication BT and BF, sir.
pulse.
Contraindication. EF and pulseless VT, contraindication, asystole and pulseless electrical activity. What is cardioversion? What conditions are treated by this?
Cardioversion
Synchronized energy.
Cardioversion refers to delivery of electric shock at time to peak of the R wave on the ECG to revert to heart normal rhythm. Mostly done as elective procedure under sedation or VA, requires less energy than defibrillation. Indications are it is hemodynamically unstable or failed pharmacological conversion of AF or atrial flutter. What are the positions of placement of electrodes for external defibrillation?
right
Can be anterior, which is called sternal and apical, or anteroposterior, anterior at the apex and posterior at the right or left intraclavicular, intrascapular regions. What are the components of a defibrillator? A machine,
ECG.
Capacitor and inductor.
It has a charging unit and a delivering unit. First of all, you can basically divide it into power source, capacitor, inductor, which arranges into charging unit, and discharging unit with a switch in between. Okay. What is AED? That is automated external defibrillator. It's a portable medical device that analyzes the heart rhythm and delivers an electric shock to restore a normal rhythm. Okay. So that is more or less talking the entire equipment and some sort of Osce also. Okay. I think the marathon session we have to put a stop at this because we have had a lot of Osce training here. Some of the slides here also were in the Osce pattern only. So I think we'll stop here, and I wish you all good luck in next week's exam. Hope all of you succeed with flying colors. Put on a lot of hard work.
Thank you, sir.
Thank you very much, sir.
Thank
Good
you
luck,
very much.
students.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Can we